to sleepy facts with Justin. Somewhere beneath the place where you are lying right now, further down than any shovel has ever reached, further down than any root or riverbed or stone foundation. The earth is warm, not warm the way a blanket is warm, or the way a cup of tea cools slowly in your hands. Warm in a deeper, older way. A warmth that has been building since before there were mountains to sit on top of it, since before there were oceans to cool its surface, since before there was anyone at all to notice. It was there. Tonight, we are going to sink into that warmth together. Slowly, gently, the way a stone sinks into still water without any hurry at all. There is a kind of mountain that breathes, not the way you and I breathe, in quick little sips of air, but in breaths that take centuries to complete. A single inhale might last longer than a human life. A single exhale might reshape a coastline. These are the volcanoes, and tonight's journey belongs entirely to them. You do not need to remember any of this. You do not need to hold on to a single fact or trace a single thread of information all the way to morning. Let the words drift past you the way clouds drift past a window, close enough to notice, too soft to grasp. If your eyes grow heavy, let them close. If your thoughts begin to blur and slow and fold in on themselves, that is exactly where they are meant to go. Picture, if you can, the deep interior of the world. Beneath the crust you stand on, beneath the thin skin of rock that holds up every forest and every field and every quiet bedroom, there is a slow churning ocean of stone, so hot it forgets what solid even means. It moves the way honey moves when it is poured from a great height, thick and unhurried, turning over on itself in loops that take millions of years to complete a single revolution. This is the mantle, and it has been turning since long before there were eyes to watch it. If you could press your palm flat against that deep stone ocean, if such a thing were possible, you would not feel a burn. You would feel something closer to a pressure, a density, a weight of heat pressing outward in every direction at once, patient and enormous, and entirely without malice. It does not wish to rise. It simply cannot help it. Heat has always moved toward cold, the way water always moves toward low ground. And deep in the earth, there is nowhere for that ancient warmth to go, but up toward the thin, cool shell where you and I happen to live, and every so often in certain places, at certain thin and weary points in the crust, that heat finds its way up. It rises the way warm air rises through a cold house, seeking any gap, any crack, any old seam where the rock has grown tired of holding itself shut. When it finds one, it pushes through, and where it breaks the surface, a mountain begins to grow. Some of these mountains rise so slowly that a human life is too short to watch them change. Others announce themselves all at once with a suddenness that has startled and humbled people for as long as there have been people to be humbled. But we are not here tonight for suddenness. We are here for slowness, for depth, for the long, unbothered patience of something that has never once been in a hurry. Volcanoes are ancient in a way that is difficult to hold in the mind. They have watched oceans open and close. They have watched continents drift apart like slow rafts on a wide, dark sea. They were here before the first fern uncurled its fronds, before the first quiet creature crawled up out of shallow water and breathed open air for the first time, and they will likely be here long after we are gone, still breathing their long, slow breaths, still turning heat into stone and stone into soil and soil into forest, over and over, in a cycle so old it has no beginning we could ever point to. There is a texture to this kind of time that is worth sitting with for a moment. A human year is a small, quick thing, gone almost as soon as it arrives. But the years that volcanoes measure themselves by are stacked in the hundreds of thousands, in the millions, layer upon layer upon layer. The way snow falls softly onto snow until an entire winter is buried beneath itself. Every layer of cooled stone at the base of a volcano is a kind of sentence in a very long, very slow book, written one eruption at a time, and read only by the patient. Tonight, we will walk gently through their story, we will look at the fire beneath our feet and the ash that once fell like gray snow over sleeping towns. We will visit islands that rose, fully formed, out of nothing but heat and patience. We will listen to the quiet instruments that scientists use to hear a mountain's heartbeat long before it ever wakes. And we will wander, eventually, far past our own planet, to the fire that burns on distant moons and dust-red worlds. But there is no need to hold on to any of it. This is not a lesson to study. It is simply a long, warm story told slowly, meant to carry you somewhere soft and unhurried, somewhere your mind can loosen its grip on the day behind you. So let your shoulders soften into the bed beneath you. Let your breathing slow to match the rhythm of these words. There is nowhere else you need to be, and nothing else you need to do except listen and drift and rest. The earth has been breathing for 4 billion years. It can certainly wait for you to fall asleep. Let us begin with a simple question, asked slowly. The way you might turn a smooth stone over in your palm before setting it down again. What is a volcano, really? Not the picture you may already be holding in your mind. The cone-shaped mountain with smoke curling from its peak. Though that image is not wrong. That is simply the surface of the answer. Tonight, we are going to go a little deeper than that. The way we go deeper than the surface of a pond to find the cool water underneath. A volcano, at its heart, is nothing more than an opening, a doorway, a place where the inside of the earth is allowed, briefly, to become the outside of the earth. That is all it has ever been in every mountain of this kind, in every age, since the planet first cooled enough to grow a solid skin, an opening, and beneath it, heat with nowhere else to go. To understand that opening, we should first understand the world it opens into. Picture the earth not as a solid ball, the way it appears from a great distance, hanging quiet and blue and still against the dark. Picture it instead as something closer to a piece of fruit. A thin skin on the outside, something softer and warmer just beneath that skin, and at the very center, a core so dense and so hot that it glows even now, even after billions of years, the way a coal glows long after the fire around it has gone quiet. The skin of this fruit is the crust, and it is thinner than you might imagine. If the whole earth were shrunk down to the size of an apple, the crust would be thinner than the apple's own peel. It is solid, and it is strong enough to hold up every mountain range and every ocean basin and every quiet sleeping town. But it is also, in a strange way, fragile. It is broken into enormous pieces, vast, slow-moving plates of rock that drift across the planet's surface, the way pieces of a cracked eggshell might drift across the surface of a bowl of water. If you were patient enough to watch them for 100 million years, beneath that cracked shell lies the mantle. And this is where our story of warmth truly begins. The mantle is rock, but rock unlike any you have ever held in your hand. Under the tremendous pressure and heat of the deep earth, this rock behaves less like stone and more like something between a solid and a very, very slow liquid. It moves, it flows, it turns over on itself in great looping currents that take millions of years to complete a single circuit. The way a pot of thick soup might turn over slowly on a very low flame. Given all the time in the world to do it, it is within this slow, warm, turning mantle that magma is born. Magma is simply rock that has grown so hot it has begun to lose its shape, to soften, to melt. The way a candle softens near its flame, but magma rarely forms because rock has simply grown hot enough on its own. More often, it forms because conditions have shifted just slightly. A change in pressure, a change in the presence of water deep underground, a slow release of the very forces that were holding that rock rigid and solid in the first place. When those conditions align, solid stone remembers, in a sense, how to become liquid again. And once it does, being lighter than the solid rock around it, it begins, ever so slowly, to rise. This is worth sitting with for a moment, because it is the quiet engine behind everything we will explore tonight. Molten rock rises for the same simple reason a bubble rises through water, or a warm breath of air rises through a cold room, it is less dense than what surrounds it. It wants, in its own patient and mindless way, to go up. And so, inch by inch, year by year, sometimes over centuries, it pushes its way toward the surface, following any weakness it can find in the crust above it, a crack, a fault line, a place where two great plates are pulling apart or grinding past one another, or one is sliding gently beneath the other into the warm dark below. When that rising magma finally reaches the surface, it takes on a new name. We call it lava. The word itself feels warm in the mouth, doesn't it? Lava. It is the same substance it always was, but transformed now by its arrival into open air, cooling and thickening, and eventually hardening into new stone. Stone that did not exist in that shape a single moment before. And this is where the volcano itself begins to take form, slowly, patiently, one layer at a time. Each time magma reaches the surface and cools, it leaves something behind. A thin sheet of hardened lava, a scattering of ash, a layer of cooled stone no thicker, sometimes, than a blanket. And then it happens again, and again, layer settling upon layer, century upon century, until what began as a simple opening in the crust has slowly built itself into a mountain, one patient breath at a time. It is a strange thing to consider that the tallest, most imposing volcanic peaks in the world were not placed there all at once. They were not carved by some sudden violent event and left standing, finished. They were built the way a candle builds a pool of wax at its base, drop by drop, over what feels, from where we sit, like an almost unimaginable stretch of time. It is worth asking, too, where all of this warmth first came from, since a planet does not simply arrive already carrying a furnace inside it. Part of that heat is left over, ancient warmth from the Earth's very beginning, from the long, violent gathering of dust and rock and ice that first drew together, pulled by its own gravity, to form the planet we now stand upon. That early warmth has never fully escaped. Stone is a poor conductor of heat, and the earth is enormous. And so, even after billions of years, much of that original warmth is still trapped deep inside, cooling at a pace so slow it is almost meaningless to measure it in human terms. But the earth also makes new heat of its own, quietly, every single day. Deep within the mantle and the core, certain elements are unstable in a very gentle, very gradual way. And as they slowly change, they release small amounts of warmth as they do. This happens constantly in every part of the deep earth. A soft and steady warming that never stops. The way a low fire needs no tending because it feeds itself. Between this ancient leftover warmth and this quiet ongoing warming, the deep earth simply never has the chance to fully cool, and so the mantle stays soft. And so magma continues to form. And so, here and there, mountains continue to rise. Beneath every volcano, whether it appears calm and silent or restless and active, there lies a network the geologists call a plumbing system. Though the phrase feels almost too ordinary for something so vast and old, deep below, there may be a magma chamber, a great reservoir of molten rock resting quietly within the crust, sometimes for thousands of years, gathering itself, warming slowly, waiting without any awareness that it is waiting. From this chamber, narrow channels called conduits rise upward, thin as the veins in a leaf by comparison to the mountain above them, offering the only path molten rock has toward the surface. Let us return now to that narrow path magma takes on its way toward the surface, because there is more worth noticing there. The conduits that carry molten rock upward are not simple straight tubes, the way you might imagine a pipe running through a wall. They are irregular, branching, sometimes widening into small chambers of their own before narrowing again, shaped entirely by the rock they pass through, taking whatever path offers the least resistance. Magma, in this sense, behaves a little like water finding its way down a hillside after rain, except moving in the opposite direction, upward, guided not by gravity, but by its own persistent buoyancy. endlessly searching for a way through. At the top of that path is the vent, the opening we associate most closely with the word volcano itself. It is here, at the vent, that the deep interior of the planet finally meets the sky. It is a small place in the end, this final threshold between the hidden and the visible, the underground and the open air, the ancient and the immediate. There is a particular quality to the air near an open vent, even a quiet one, that travelers and scientists alike have described in oddly similar terms across many centuries and many languages, a faint mineral warmth, a stillness that feels older than the wind moving through it. Sometimes a thin curl of vapor, rising without any hurry, dissolving into the sky the way a slow breath dissolves into cold morning air. It is not violent. It is simply patient heat finding the smallest, most honest way to let itself out. Not every volcano behaves the same way when that meeting happens. Some release their heat gently in slow rivers of glowing stone that creep across the land at a walking pace, allowing plenty of time for anyone nearby to simply step aside and watch. Others build pressure quietly for long stretches before releasing it all at once, in a manner far more sudden. We will spend time with both kinds of behavior later in our journey together, examining the different shapes and temperaments these mountains can hold. But for tonight, in this first quiet chapter, it is enough simply to hold the shape of the idea itself. A volcano is not a monster. It is not an enemy of the land it rises from. It is, instead, something closer to a very old, very patient chimney, connecting the deep, warm heart of our planet to the cool, open air above, allowing pressure to be released slowly rather than allowed to build forever without any outlet at all. In this sense, volcanoes are less a symbol of destruction and more a symbol of balance, of a planet quietly managing its own restless inner warmth, the same way your own body, right now, manages its own gentle heat, releasing it softly through your skin as you rest. There is something almost comforting in this, if you let yourself sit with it. The earth beneath you, holds up your house and your street and every familiar place you have ever known is not a cold, dead, unmoving thing. It is alive with slow motion, warmed from within, shifting and turning, and breathing in a rhythm so unhurried that an entire human lifetime passes like the blink of an eye against it. As you drift further into rest tonight, you might imagine yourself sinking gently past the surface of the world, past the soil and the roots and the stone, down into that warm, slow mantle where rock moves like something between water and memory. There is no danger in this image, no need for alarm. There is only warmth and depth and the quiet knowledge that everything beneath you has been patiently, gently turning over for longer than any of us can truly imagine, and will go on turning long after this night has ended. Rest now in that thought. The mountain does not hurry, and neither must you. Let your own breathing settle into something just as slow, just as unbothered, just as certain that morning will arrive, whether it is watched for or not. If you were to look down on the earth from very far above, from a height where oceans lose their waves and mountains lose their sharp edges, and everything softens into color and shape, you would notice something curious. The volcanoes of the world are not scattered randomly, the way raindrops might scatter across a window. They gather. They follow lines. They trace long, curling paths across the surface of the planet, as though someone, long ago, had drawn a gentle border around certain regions and left the rest of the world in relative quiet. The most famous of these paths circles almost the entire Pacific Ocean, and it has come to be known in a phrase that sounds almost like something from an old folk tale as the ring of fire. Tonight, let us trace that ring together slowly, the way you might trace the rim of a warm cup with one finger, feeling your way along its curve without any need to hurry toward the other side. There is no test at the end of this tracing, only the shape of the world itself, offered gently for you to rest inside. To understand why volcanoes gather where they do, we return gently to something we touched on before, the idea that the Earth's crust is not one solid shell, but many enormous fractured pieces, drifting slowly across the softer rock beneath them. These pieces are called tectonic plates, and they move at a pace so slow it can hardly be called movement at all by human standards. A few centimeters a year in most places, about the same rate your fingernails grow, and yet, given enough time, and the earth has always had enough time, this creeping, patient drift is enough to open oceans, raise mountain ranges, and carry entire continents from one side of the globe to the other. It is where these great plates meet along their edges that volcanoes tend to gather most thickly, and the ring of fire is simply the vast circle traced by one plate meeting many others, all around the rim of the Pacific. Picture it this way, if it helps. The floor of the Pacific Ocean is its own enormous plate, and around nearly its entire border, that plate is pressing against its neighbors, sometimes sliding beneath them in a slow process geologists call subduction, sometimes grinding alongside them, sometimes pulling gently away. Each of these interactions, in its own way, creates the conditions volcanoes need. Where one plate slides beneath another, it carries down with it water trapped in ancient seafloor sediment, and that water, reaching the hot rock of the mantle below, lowers the melting point of the stone around it, coaxing solid rock into softening into magma far more easily than it otherwise would. It is a little like how a pinch of salt lowers the melting point of ice, allowing it to soften and give way at a temperature it would otherwise resist. There is a rhythm to this process worth lingering on as one plate slides beneath another. It does not do so smoothly, the way a drawer slides shut. It moves in fits and starts, catching against the plate above it, holding still for long stretches, then releasing all at once in a sudden shift before catching and holding again deep below. This same slow catching and releasing bends and folds the rock above the sinking plate, cracking it in places, thinning it in others, opening exactly the kind of pathways that rising magma needs to find its way toward the surface. In this sense, the volcanoes along a subduction zone, and the earthquakes that so often accompany them are not two separate stories at all, but two expressions of the very same deep, slow, grinding process. Walk with me for a moment along one small stretch of this vast ring, simply to feel its scale. Along the western edge of South America, the long chain of the Andes rises, where an oceanic plate slides beneath the continent, feeding a string of volcanic peaks that stretches for a distance longer than the whole length of many countries put together. Some of these mountains have stood quiet for centuries. Others stir gently from time to time, venting soft plumes of steam into thin mountain air, watched patiently by the small villages that have learned to live in their shadow for many generations further north, through the narrow bridge of land connecting two great continents. More volcanoes rise in a similar pattern, feeding rich, dark soil that has drawn farmers to their slopes. For as long as there have been farmers at all across the wide breadth of the Pacific, in the island nations of Japan, the Philippines, and Indonesia, the pattern repeats itself again. Plate after plate meeting and sliding and releasing, building volcanic islands that rise directly out of the sea, their peaks often wrapped in soft cloud, their lower slopes thick with green growth, nourished by the very ash that occasionally falls from above. It is a strange and gentle paradox, one we will return to later in our journey, that some of the most fertile farmland on the entire planet lies closest to the mountains most capable of dramatic change. The land, it seems, does not forget what has been given to it, even long after the memory of how it arrived has faded. This single quiet chemical gift, water carried down into darkness, is responsible for a remarkable share of the volcanic activity found along the entire ring of fire, from the southern tip of South America up the long spine of the Andes through Central America, along the western coast of North America, up through the volcanic chains of Alaska, and then curving downward again through the Kamchatka Peninsula, through Japan, through the Philippines, through Indonesia, and further still down toward New Zealand, closing the circle at last, it is worth sitting for a moment with just how enormous this ring truly is. It touches dozens of countries. It passes near hundreds of millions of people, most of whom go about their daily lives with barely a thought for the deep, slow forces working beneath their homes. It contains the great majority of the world's active volcanoes, along with the great majority of the world's earthquakes. Since the same restless plate boundaries that build volcanic mountains also shift and grind, and occasionally release the tension that gathers along their edges. And yet, for all this activity, the Ring of Fire is not the only place on Earth where volcanoes gather. There are other patterns, quieter in some ways, gentler in others, that reveal themselves once you begin to look closely at the shape of the world. Consider the long crack that runs down the middle of the Atlantic Ocean, hidden entirely beneath the waves, where two great plates are slowly pulling apart from one another rather than colliding. This is called a divergent boundary. And rather than pushing plates together, it gently tears them apart, allowing warm material from below to rise up and fill the widening gap, cooling into new ocean floor as it goes. This hidden mountain range, called the Mid-Atlantic Ridge, is in fact the longest chain of volcanic mountains on the entire planet, and almost none of it can be seen, since nearly all of it lies far beneath the surface of the sea. It winds down the length of the Atlantic like a long, slow spine, invisible to anyone standing on the shores of the continents it separates. And yet, it has been quietly widening the ocean above it for longer than there have been continents in their current shape at all. Every year, the gap widens by roughly the same small distance a fingernail grows, and every year, fresh warm rock rises to fill that widening seam, cooling into new stone the moment it meets the cold water of the deep sea. There is something almost tender about this kind of volcanic activity, so different in temperament from the restless grinding of the Ring of Fire. Along a divergent boundary, nothing is being forced together or dragged beneath anything else. The plates are simply, slowly letting go of one another, drifting apart at the gentlest possible pace, and the earth beneath them rises softly to fill whatever space is left behind. The way water rises quietly to fill a space left by a lifted stone. Only in a few rare places does it rise high enough to break the surface and become visible land. And we will spend time later in our journey with one particularly beautiful example of that rare occurrence. There is also a third kind of volcanic geography, stranger and more solitary than the other two. That has nothing to do with the edges of tectonic plates at all. In certain places, deep plumes of unusually hot rock rise from far below the mantle, piercing straight up through the middle of a plate rather than along its edge. The way a candle flame might burn straight through the center of a piece of paper rather than along its border. These are called hot spots, and they can produce volcanoes in the most unexpected places, far from any plate boundary, seemingly in the middle of nowhere at all. What makes them especially curious is that the hot spot itself tends to stay remarkably still, fixed deep in the mantle, while the plate above it drifts slowly across it over millions of years. The way a piece of paper might drift slowly across a candle flame, held steady beneath it. The result, when enough time has passed, is not a single mountain, but an entire chain of them, each one marking the place where the plate once sat directly above the heat before drifting onward, leaving that mountain to grow quiet and cool, while a new one begins to rise behind it. We will return to this quiet mystery in more detail soon, because it holds one of the gentlest and most elegant stories in the whole history of volcanic science. For now, though, let us simply hold the wider picture. The volcanoes of the world are not scattered by chance. They follow the deep architecture of the planet itself, tracing the edges of drifting plates, marking the seams where the Earth's crust is thinnest, weakest, most willing to let its inner warmth escape. Some trace long curving rings around entire oceans. Some hide beneath the sea, unseen for millions of years. Some rise up alone, far from any boundary at all following heat that has traveled up from depths far below the plates themselves. There is something quietly reassuring in this pattern if you allow yourself to feel it. The world is not random in the way it releases its pressure. It has found its own paths, its own seams, its own quiet places to breathe, in the same way your own body finds its rhythm each night, slowing gradually, releasing the tension of the day through slow breath and softening muscle. The earth, too, has found its own steady places to let go of what builds within it. As you rest here tonight, you might imagine yourself drifting high above the surface of the world, the way we began this section, looking down at oceans and continents from a great, gentle height. Picture that long, curling ring tracing its way around the Pacific, glowing faintly here and there with a soft, warm light. Each point along its path, a small, patient opening where the earth quietly lets its breath escape. There is no danger in this image, only pattern, only rhythm, only the calm, ancient geometry of a planet that has always known exactly where to release what it carries. Let that image settle over you now, soft and wide and slow. And let your own thoughts trace their own gentle circle, round and round, unhurried and unbroken, until sleep finally, quietly arrives. We have already touched gently on the idea that solid rock can soften and rise as magma. Tonight, let us slow down even further and sit with that transformation itself. Unhurried, the quiet moment when something solid remembers at its own pace how to flow. This is worth saying plainly to begin. That rock does not melt the way ice melts, or the way wax melts near a flame. All at once, at one single fixed temperature, the same way every time. Rock is not one substance, but a mixture of many different minerals, each with its own particular threshold for melting, its own particular resistance or willingness to soften. Because of this, when rock begins to melt deep within the earth, it does not transform completely and immediately from solid to liquid. Instead, it melts partially, a small percentage of its minerals loosening and turning liquid first, while the rest remains solid around it, held together in a kind of soft, slushy suspension, not unlike a block of ice that has just begun to soften at its edges, while its center remains hard and cold. This partial melting is, in fact, almost always how magma is born. Only rarely, and only under very particular conditions, does rock ever melt completely. Far more often, it is this gentle, partial process, small amounts of liquid slowly gathering, slowly separating from the solid rock around them, slowly rising because they are lighter, that produces the magma we have been following on its journey toward the surface. There is an order to this softening. 2. A quiet sequence that repeats itself again and again in rock all across the world, in slow chambers no human eye will ever directly see. Certain minerals give way first, softening at comparatively modest temperatures, while others hold their shape far longer, resisting until the heat around them grows considerably more intense. It is a little like watching a whole quiet household slowly wake in the early morning hours, one member rising first while the rest continue to rest, then a second stirring, then a third, until eventually the entire house is awake, though never all at the same single moment. In rock, this means the very first droplets of liquid to form are usually quite different in character from the rock around them, richer in certain elements, lighter, far more willing to flow freely. These early droplets are often what eventually become the magma that travels furthest and fastest toward the distant surface, having separated earliest from the slower, more stubborn material left quietly behind. There are 3 quiet paths by which the deep earth accomplishes this gradual softening. And tonight we will walk unhurried through each one, taking our time, the way you might walk 3 different paths through the same familiar garden, each one leading eventually to the same warm center. The first path is called decompression melting, and it may be the gentlest and most elegant of the 3. Deep in the mantle, rock sits under tremendous pressure, pressed down by the enormous weight of everything above it. This pressure, strangely enough, helps keep the rock solid even at temperatures that would otherwise be more than hot enough to melt it. The pressure holds the mineral structure together, the way a tightly closed fist can hold sand that would otherwise spill through open fingers. But if that rock begins to rise, carried upward by the slow churning currents of the mantle itself, the pressure around it gradually lessens. And as the pressure lessens, without any change in temperature at all, the rock can suddenly find itself able to melt, simply because the force that had been holding it solid has loosened its grip. This is the process most responsible for the magma rising beneath the mid-Atlantic ridge and other places where plates are gently pulling apart, allowing mantle rock to rise and ease itself open, softening not because it has grown hotter, but because it has finally been given room to soften. It is a strange thing to consider that in this particular corner of the Earth's slow chemistry, rising is itself the cause of melting, rather than the result of it. The rock does not soften and then rise the way we might ordinarily imagine it. It rises, and only then, freed at last from the great crushing weight above it, does it discover, almost by surprise, that it is able to soften at all. The second path we touched on briefly before, in our exploration of the great circling boundaries of the ring of fire. This is called flux melting, and it depends not on pressure, but on the presence of water. When one plate slides beneath another, it carries with it water trapped deep within ancient seafloor sediment, water that has been locked into the structure of certain minerals for millions of years. As that descending plate sinks deeper into the hot mantle, heat and pressure eventually force this trapped water to release, and once free, it rises into the mantle rock just above it. Water in this setting acts almost like a key turning in a lock. It does not need to add extra heat to the surrounding rock at all. It simply lowers the temperature at which that rock is willing to melt, the same gentle way salt lowers the temperature at which ice is willing to remain frozen. Rock that might have stayed comfortably solid without any water present suddenly finds itself softening, loosening, beginning its slow transformation into magma, all because of a small trace of moisture carried down from a seafloor far above. This is, in its own way, one of the most patient and remarkable journeys in this entire story. That water first fell as rain, perhaps, or gathered in some ancient ocean, was drawn down into seafloor sediment over thousands of years, was carried further still on the slow back of a sinking plate for millions of years more. And only then, after that impossibly long and quiet journey, finally performed its small, decisive task deep within the mantle, releasing rock from a solidity it had held for far longer than any of us could easily imagine. The third and final path is the most straightforward of the three, though no less remarkable for its simplicity. This is heat transfer melting, and it occurs when unusually hot material rises from very deep within the earth, from the boundary near the core itself, carrying with it warmth far beyond what the surrounding mantle typically holds. As this deep, hot material pushes upward, it can come into contact with cooler rock above it, transferring its heat directly, the way a warm hand resting against a cold window pane slowly warms the glass beneath it. If enough heat transfers in this way, the cooler rock above may begin to melt on its own, not because pressure has released it, and not because water has lowered its threshold, but simply because it has been given enough direct warmth to soften. This process asks for nothing clever, nothing chemical, nothing dependent on timing or pressure. It is warmth meeting cold, patiently, steadily, for as long as it takes. The same simple exchange that warms a cool room once a fire has been lit within it, given only enough time to do its quiet work. This is the process most closely associated with the deep, narrow plumes that create hot spots, rising columns of unusually warm material reaching up from far below, patiently warming whatever solid rock happens to lie in their path. It is worth pausing here to notice something quietly beautiful about these three paths. Each one describes a different kind of gentleness. One softens rock by simply loosening its grip softens rock by offering it a small, quiet key. And one softens rock through nothing more than patient, direct warmth, given generously over a very long time. None of them are violent processes in themselves. They are closer to persuasion than to force, closer to coaxing than to breaking. Rock, in each of these cases, is not destroyed or shattered into liquid. It is invited slowly, gently, by pressure or water or warmth, to loosen just enough to flow. And it is worth noticing, too, that these three paths rarely act entirely alone. In many places deep beneath the surface, more than one of these gentle persuasions is at work at the very same time. Pressure easing in one pocket of rock, while a trace of water softens another nearby, while somewhere close by, a slow current of extra warmth adds its own quiet influence to the mix. The earth, it seems, rarely relies on just one method when several will do, layering its patience the way a good blanket layers warmth, not through any single thick fold, but through many soft ones gathered together, each one doing a small share of the work, none of them needing to carry the whole task alone. Once that softening begins, and small pockets of liquid rock begin to form within the surrounding solid, something else quietly occurs. These small droplets of melted rock, lighter than the solid material around them, begin to gather together, the way small drops of water on a cool window slowly find one another and merge into larger drops. Over time, enough of these droplets combine to form larger, more substantial pockets of magma, capable at last of pushing their way upward through cracks and weaknesses in the rock above, beginning the same long, unhurried rise we have already followed once before. This gathering does not happen quickly, nor does it happen evenly. In some places, droplets combine readily, drawn toward one another by gravity and by the simple fact of their shared lightness. In other places, the surrounding solid rock is stubborn, tightly packed, unwilling to release the small pockets of liquid forming within it. And the gathering slows, sometimes for a very long while, before finally continuing, patiently, without complaint, the way all slow things eventually do. It is not unlike the way sleep itself can arrive in uneven stages, quickening in one quiet stretch, slowing again in another, before finally, eventually, gathering into something whole and settled. There is a particular kind of patience in this image worth carrying with you tonight. Nothing about the birth of magma is sudden. It begins as the smallest imaginable softening. A single mineral here, a small fraction of a percentage there, gathering slowly over spans of time too long for a single mind to hold clearly, and yet, given enough patience, enough gathering, enough quiet accumulation, these smallest beginnings eventually become the vast molten reservoirs that feed volcanoes all across the world. Perhaps there is something worth borrowing from this image as you rest here tonight. You do not need to soften all at once either. Sleep, like magma, tends to arrive not through force, but through small, quiet releases, one gentle loosening after another, until enough softness has gathered that the mind, at last, is ready to flow easily into rest. There is no need to hurry that gathering. There is no need to force the softening. It happens on its own time, the way it always has, the way the deep earth has always known how to let its own solid places quietly, patiently become fluid. No part of you needs to melt completely, all at once, before rest can arrive. A small percentage will always be enough to begin the slow, warm gathering that carries you the rest of the way. Let your own thoughts loosen slowly now, the way pressure loosens deep stone, the way water lowers a threshold, the way warmth slowly persuades what was once solid to soften. There is nowhere else to be, and nothing left to hold onto tightly. Simply let go, one small, quiet piece at a time, and rest. The way the deepest rock has always, eventually, let go and rested and softened into something new. Not every single volcano in the world wears the same shape. If you were to gather images of volcanoes from all across the world and lay them side by side, the way you might lay a collection of old photographs across a table, you would notice quite quickly that they do not resemble one another nearly as closely as you might expect. Some rise in wide, gentle domes, so gradual in their slope that a person could walk up one side without ever quite noticing they were climbing a mountain at all. Others tower steeply, sharp and symmetrical, capped in snow, looking every bit like the picture most of us carry in our minds when we hear the word volcano. And still others are small, humble little hills, barely more than a mound of loose, dark stone, built in what amounts, on a geological scale, to almost no time at all. Tonight, let us walk slowly through these different shapes, the way you might walk quietly through a gallery after closing hours, when the light is low and there is no need to hurry past any single piece, pausing exactly as long as feels comfortable before moving on. The first shape belongs to the shield volcano, and it takes its name from its gentle, rounded profile, said to resemble the curved shield of an ancient warrior laid flat upon the ground. These are the broadest volcanoes in the world, often stretching for many miles across their base, while rising only a modest distance into the sky. Their slopes so gradual that from a distance they can look almost like ordinary hills rather than volcanoes at all. The reason for this wide, gentle shape lies entirely in the nature of the lava that builds it. Shield volcanoes are built from lava that is unusually thin and fluid, quick to flow, quick to spread, unwilling to pile up steeply the way thicker material would. Picture warm honey poured slowly onto a flat plate, spreading outward in every direction rather than gathering into a tall mound. This is very much how a shield volcano grows, one thin flow after another, each one spreading far and wide before finally cooling, layer settling gently upon layer, gradually building height only very slowly. Only after a great many flows have accumulated across a very long stretch of time. This thinness comes down to a quiet matter of chemistry, though there is no need to hold on to the details tonight. Lava that is low in a mineral called silica tends to flow easily, the way water flows easily compared to syrup, while lava rich in silica behaves in a thicker, more reluctant way, more like syrup left too long in a cold refrigerator. Shield volcanoes draw their gentle character from this low silica lava, rising from deep, relatively uniform sources within the mantle, rather than from the more complicated mixtures that feed other volcanic shapes. Because this lava resists piling up, it can travel remarkable distances from its source, sometimes many miles, before finally slowing and cooling into new stone, which is precisely why shield volcanoes can grow so wide while never growing especially steep, because this fluid lava moves so easily. Eruptions at shield volcanoes also tend to be far gentler than many people imagine, given the fearsome reputation volcanoes often carry. Rather than explosive bursts, these mountains often release long, glowing rivers of lava that creep across the land at an unhurried walking pace, giving plenty of warning, plenty of time for anyone nearby to simply step aside and watch from a comfortable distance the great volcanic mountains of Hawaii, which we will spend more time with soon, are perhaps the most famous examples of this gentle shape, built slowly, patiently, from countless thin flows of fluid lava spreading outward across the seafloor and beyond, over spans of time too long to easily hold in mind. The second shape belongs to the stratovolcano, and this is very likely the shape you already picture when you imagine a volcano in your mind's eye. Tall, steep-sided, often perfectly symmetrical, tapering to a narrow peak, sometimes capped in snow even in warmer seasons. Thanks to the height these mountains are able to reach, where shield volcanoes are built from thin, easily flowing lava, stratovolcanoes are built from something thicker, stickier, far less willing to spread out gently across the land. This thicker lava does not travel far before cooling and hardening. And so, instead of spreading into wide, flat sheets, it piles up close to the vent that produced it, building height quickly rather than width. Stratovolcanoes are also called composite volcanoes, a name that reflects how they are built, not from lava alone, but from alternating layers of hardened lava and volcanic ash, one stacked upon upon the other, again and again. The way a tall cake might be built from alternating layers of cake and filling, each layer distinct from the one beneath it, yet all of them together, forming one tall, unified structure. This alternation happens because a single stratovolcano rarely behaves the same way twice in a row across its long life. One eruption might release a thick tongue of lava that hardens close to the vent. The next might release mostly ash and fragmented rock, blasted skyward and settling gently back down across the slopes below. Over centuries, these different kinds of material stack atop one another in an irregular but sturdy pattern, giving stratovolcanoes their considerable strength and their tall, enduring shape, strong enough to rise far higher than the gentler shield volcanoes ever manage, precisely because each layer helps brace and support the ones above it, because the lava within a stratovolcano is thicker and stickier. It also tends to trap gas far more easily than the thin lava of a shield volcano. Gas bubbles rising through thick, sticky material struggle to escape gently, clustering and gathering, rather than slipping quietly free the way they might in thinner lava. And when enough pressure builds beneath that stubborn cap, it can be released quite suddenly, all at once, producing far more forceful eruptions than the gentle rivers of a shield volcano typically allow. This is not a cause for alarm as you rest here tonight. It is simply the nature of stickier material, unable to release its pressure quite as gradually or as gently as thinner lava can. Some of the most famous mountains in human history belong to this shape, tall and symmetrical and steeped in old stories, and we will return to several of them individually in the sections ahead. The third shape, smaller and humbler than the other two, belongs to the cinder cone, and it may be the simplest volcano of all, at least in terms of how it forms. Cinder cones grow quickly, at least by the patient standards of geological time, sometimes rising to their full modest height within only a few years or even a single season of activity. They form when gas-rich lava is thrown into the air through a single vent, breaking apart as it flies, cooling rapidly in the open air into small, light, cindery fragments that then fall back to the ground surrounding the vent, piling up into a small, steep, cone-shaped hill, unlike the wide, gentle slopes of a shield volcano or the towering symmetrical height of a stratovolcano. A cinder cone rarely grows taller than a few hundred body lengths, a modest hill by comparison, though no less remarkable for its speed of formation and the simplicity of its shape. There is a pleasing simplicity to how a cinder cone builds itself, worth sitting with for a moment. Each fragment thrown into the air follows its own small arc, cooling as it rises and falls, landing somewhere near the vent that launched it, and settling into place almost immediately, with none of the slow accumulation of countless thin flows, or the patient stacking of layer upon differing layer. A cinder cone is built, in a sense, all at once, through a single sustained burst of activity, then left largely unchanged for the long, quiet centuries that follow. A brief chapter written quickly and then closed. Cinder cones often appear not as solitary mountains standing alone, but as smaller companions gathered near the base of a much larger volcano, or scattered here and there across a wider volcanic landscape. Small, quiet reminders of brief, localized bursts of activity that came and went far more quickly than the long, patient centuries required to build their larger neighbors. There is a fourth shape, quieter still, worth a brief mention before we move on, where lava is especially thick, so thick it barely flows at all. It can pile up directly over its own vent, forming a rounded lava dome rather than spreading outward in any direction. These domes grow slowly, almost reluctantly, thick material inching upward and outward at a pace so unhurried it can sometimes be measured by eye across a single patient afternoon, forming a rounded mass that looks, from a distance, a little like a great loaf of bread left to rise undisturbed. It is worth noting gently that these four shapes are not entirely separate categories, with hard, unmoving borders between them. The natural world organizes itself into such tidy divisions. Some volcanic landscapes combine more than one shape entirely. A cluster of small cinder cones scattered across the flank of a broad shield volcano, or a stratovolcano that has, at some point in its long history, also produced gentler, more fluid flows, more typical of its wider cousin. Nature borrows freely from each pattern whenever conditions allow. And the three shapes we have walked through tonight are best understood not as strict categories, but as general tendencies. Three common answers to the same underlying question of how thick or thin, how gassy or how calm the rising material happens to be. What determines which shape a volcano will take in the end comes down almost entirely to the character of the magma feeding it, how thick it is, how much gas it carries, how easily it flows once it reaches the open air, thin and fluid, and a mountain spreads wide and gentle, thick and sticky, and a mountain rises steep and tall, layer by careful layer, full of gas and thrown briefly into the air, and a small, quick hill of loose fragments gathers itself together in a single, humble season, thick beyond flowing altogether, and a quiet dome simply rises in place, patient and rounded, never traveling far from where it first appeared. There is something worth carrying with you from this idea as you drift further toward rest tonight. Shape, in the end, is simply the visible record of temperament. A wide, gentle mountain tells you, without a single word, that whatever built it moved easily, unhurried, spreading itself calmly across a broad and patient landscape. A tall, steep mountain tells you that whatever built it held its shape closely, releasing itself only in careful, deliberate layers. And a small, quiet cone tells you that something briefly rose, released itself quickly, and then settled back into stillness. Perhaps you might imagine as you rest that your own thoughts tonight could take whichever shape suits them best. Some may spread wide and thin and gentle, easing outward without any hurry at all. Others may need to settle in careful, quiet layers, one small release following another. And some may simply need one brief moment letting go before settling quickly and completely into stillness. There is no wrong shape for rest to take. There is only the shape that comes naturally, the way it always has, to whatever is ready to let go. Let your own mind soften now into whichever shape feels most like home tonight, wide or tall or small or slow and rounded, gentle or layered or brief, and rest there, unhurried, exactly as you are, taking whatever form comes most naturally. We have already spent some time in an earlier chapter of this long journey together with the quiet underground architecture that makes a volcano possible, the deep chamber where magma gathers, the narrow conduit that carries it upward, the vent where it finally meets open air. Tonight, let us follow that same path once more, but slower still, paying attention this time not to the architecture itself, but to the process, the long unfolding sequence of events that carries stone from stillness into motion, and finally back to stillness again. Every eruption, however dramatic or however gentle it may turn out to be, begins in a place of almost complete quiet. Deep within a magma chamber, molten rock rests quietly, sometimes for centuries, sometimes for far longer still, gathering itself slowly, warmed continually by the same deep processes we explored earlier. But magma is rarely a simple, uniform liquid. Dissolved within it, invisible to any eye, are gases, water vapor mostly, along with smaller amounts of other gases, all held in solution, the way sugar dissolves invisibly into warm water, present but unseen. These dissolved gases are the quiet key to almost everything that follows. As magma sits within its chamber, deep beneath tremendous pressure, these gases remain peacefully dissolved, held in place by the same crushing weight of rock above that we discussed when we first spoke of decompression melting. But should that magma begin to rise, even slightly, toward the surface, the pressure surrounding it begins to ease, and just as a bottle of sparkling water releases its bubbles the moment its cap is loosened, the gas dissolved within the rising magma begins to come out of solution, forming countless small bubbles throughout the molten rock. This process, which scientists sometimes call exsolution, tends to begin at a particular depth within the conduit, a depth that depends on how much gas the magma originally carried and how quickly it happens to be rising below that depth. The gas remains obediently dissolved, invisible, patient. Above it, tiny bubbles begin to nucleate. First, no larger than the finest grains of sand, scattered thinly throughout the rising magma as the magma continues its ascent and pressure continues to ease. These bubbles do not simply stay the same size, they expand. The way any gas expands when the pressure holding it in check is gradually released. And as they expand, they also begin to merge with their neighbors. Smaller bubbles joining into larger ones joining into larger ones still. The way small clouds on a summer afternoon can drift together into something far broader than any one of them began. This single quiet transformation, gas leaving solution to form bubbles, is the true engine behind almost every eruption, gentle or forceful alike. However different the surface drama may eventually look, everything that follows depends entirely on how easily those bubbles are able to escape. In magma that is thin and fluid, the kind that feeds the wide, gentle shield volcanoes we spent time with before, these gas bubbles rise and escape with relative ease, slipping upward through the liquid rock, the way bubbles rise easily through a glass of water, reaching the surface and releasing their gas quietly into the open air because the gas escapes so readily. Pressure rarely has the chance to build to any dramatic degree, and the eruption that follows tends to be correspondingly gentle. A slow, effusive release of lava, accompanied by little more than a soft hiss and a faint plume of steam, but in magma that is thick and sticky, the kind that feeds the steep stratovolcanoes we also explored. Those same gas bubbles struggle to rise freely. The thick surrounding material resists their movement the way honey resists the rise of a bubble far more than water does. And so the bubbles remain trapped, growing larger, gathering in greater numbers, unable to release their pressure gradually. Instead, pressure builds steadily within the rising magma, sometimes for weeks, sometimes for months, occasionally for years. The surrounding rock straining quietly to contain something that very much wants to expand. Eventually, in these thicker, gassier systems, the pressure inside the rising magma comes to exceed the strength of the rock, still holding it in place. And when that threshold is finally crossed, the result is what we typically picture when we imagine a volcanic eruption in its most forceful form. The magma, suddenly freed, expands with tremendous speed, gas bubbles bursting apart almost instantly as pressure releases all at once, tearing the surrounding magma into countless small fragments. As it does, these fragments, some no larger than fine dust, others as large as a fist or larger still, are thrown violently upward, carried by the same expanding gas that tore them apart, rising together into what scientists call an eruption column, a tall, dark plume that can, in the most forceful eruptions, climb many miles into the sky above. Within this rising column, hot gas and countless fragments of shattered rock move together, cooling gradually as they climb. The smallest and lightest fragments carried highest, sometimes drifting for great distances before finally settling back down as fine ash, dusting the landscape below in a soft gray layer that can, in time, become wonderfully fertile soil. A quiet gift we will return to later in our journey. The larger, heavier fragments fall back closer to the vent that produced them, gathering there, sometimes contributing to the same layered structure that builds a stratovolcano's tall, symmetrical shape over many centuries of repeated activity. Sometimes, rather than rising cleanly into the sky, a portion of this hot mixture of gas and fragmented rock instead loses its buoyancy partway up and collapses back downward, flowing swiftly along the ground rather than continuing skyward. When this happens, it moves as a dense, fast-moving current of hot gas and ash hugging close to the slopes of the mountain, following valleys and low ground the way water might, though moving with far greater speed than any ordinary river, these ground-hugging currents are considered among the most powerful and forceful expressions of an eruption's energy, though they are also, mercifully, among the most predictable in terms of where they are likely to travel, since they tend to follow the same low pathways that ordinary water would, allowing careful mapping of the areas most likely to lie in their path long before any eruption ever begins. Not every eruption follows this single forceful pattern all the way through, and it is worth noting that most volcanic activity, even at the more explosive stratovolcanoes, tends to unfold gradually rather than in one single overwhelming burst. An eruption may begin with a period of gentle unrest, small earthquakes deep below, as rising magma cracks and shifts the rock around it. Subtle swelling of the ground surface as the mountain quietly stretches to accommodate the material rising within it. Faint increases in the temperature or composition of gases escaping from vents near the summit. These early signals unfold slowly, often over weeks or months, sometimes longer, and each one tells its own small part of the story. The small earthquakes mark magma forcing its way through rock that was never quite shaped to allow its passage, cracking gently as it goes, the way ice cracks quietly across a pond in the earliest stages of a thaw. The swelling of the ground, meanwhile, happens because the volcano itself is, in a very literal sense, filling with something new. The whole mountain rising by some small fraction as magma gathers beneath it. A change so gradual it can only be measured with careful instruments rather than felt underfoot, and the shifting character of escaping gases offers a kind of chemical whisper from deep below, a slow change in composition that hints, long before anything is visible at the surface, that fresh material is drawing nearer. These early, quiet signals are precisely what the patient scientists we will meet later in our journey spend their careful attention watching for, long before any dramatic activity ever begins. Once an eruption is fully underway, it may continue for hours, for days, occasionally for months, alternating between more explosive explosive phases and quieter effusive phases as conditions within the magma chamber and conduit shift and change. A single eruption is rarely one single moment. It is closer to a long, uneven conversation between rising pressure and available release, sometimes calm, sometimes forceful, continuing until the magma driving it has either exhausted itself or found some other quieter way to relieve the pressure that built it. This uneven quality often traces back to changes happening deep within the magma chamber itself as an eruption continues. Early material to reach the surface may come from nearer the top of the chamber, where gas has had longer to gather and pressure has built most fully, producing the more forceful opening phases many eruptions are known for. As the eruption continues and this upper material empties out deeper, sometimes less gas-rich magma may rise to take its place, arriving at the surface with a gentler temperament, tapering the eruption gradually toward its quieter final phases, rather than ending it all at once. In this sense, an eruption is not one uniform event, but a kind of layered unveiling, each phase revealing a slightly different portion of the chamber that fed it. From most restless to most settled, the way a long exhale might begin forcefully and slowly soften toward its natural end. There is one more pattern worth mentioning tonight, gentler in its trigger, though not always gentler in its result. Not every eruption requires fresh magma to reach the surface at all. Sometimes, rising heat alone is enough to bring a hidden eruption to life. When groundwater trapped within the rock surrounding a volcano's plumbing suddenly encounters that heat and flashes almost instantly into steam. Water expands enormously when it becomes vapor, far more than most other substances. And when that expansion happens suddenly, confined within solid rock that has no gentle way to accommodate it, the surrounding stone can shatter and burst outward with considerable force, throwing older, already cooled rock into the air rather than fresh molten material. These steam-driven eruptions can occur with very little warning. since they do not always require new magma rising from below. Only existing heat meeting water that happens at last to have found its way into contact with it, and then eventually, always without fail, the eruption subsides. The magma remaining in the conduit cools and hardens, sometimes sealing the pathway entirely, sometimes leaving it open, but quiet, ready to be used again, should pressure ever gather in the same place once more. The chamber below settles back into its long, patient rest, gathering itself slowly, warming gradually and quietly, waiting without any awareness of waiting for whatever comes next, whether that is another eruption within a human lifetime, or a silence that stretches on for many centuries more. There is a rhythm in this entire sequence worth carrying with you as you rest here tonight. A rhythm of gathering and release, of pressure quietly building, and then, eventually, finding its way toward calm again, the way it always eventually does. It is not so different in its shape from the rhythm of your own breath. Each inhale a small gathering, each exhale a small release, over and over, without any need for force or hurry, simply the natural unwinding of something that has built up and is now gently letting go. Let your own breathing settle into that same unhurried rhythm now. A slow gathering in, a slow release out, each breath asking nothing more of you than the last, each one carrying you a little further from waking and a little closer to rest. There is no pressure here that needs to build, and nothing left to hold on to. There is only this soft, repeating rhythm, gathering and releasing, gathering and releasing, until sleep, quietly and completely, arrives. There is a small, precise moment, easy to overlook entirely, when molten rock quietly changes its name. Below the surface, it is magma. The instant it crosses into open air, spilling from a vent or fissure, it becomes lava. Nothing about the substance itself changes in that brief instant. The same minerals, the same heat, the same slow molten weight. And yet, once it meets the sky, we begin calling it something else entirely, as though its arrival in our world deserved its own separate word, its own smaller ceremony of naming. Tonight, let us sit with that transition, and with everything that unfolds afterward. Once molten rock has left the patient dark of the underground and stepped, glowing, into open air for the very first time in its long existence. The word magma, when you trace it back far enough, comes from an old word meaning a thick paste or ointment. And there is something fitting in that origin, since magma beneath the surface behaves very much like a thick paste, held under pressure, moving slowly, resisting easy definition. Lava, by contrast, comes from a word associated with a flowing stream, and this too fits its character well. Since the moment molten rock reaches open air, released from the crushing pressure of the rock above it, it begins, for the first time, to behave as something closer to a true liquid, flowing visibly, however slowly, across the surface of the land. It is worth pausing on just how quickly this transformation in behavior takes place. In the span of only a few heartbeats, molten rock passes from an environment where it has spent centuries or millennia held in patient, crushing stillness, to an environment where it suddenly answers to gravity in the open, unguarded way that any liquid does, spreading, seeking low ground, cooling against the touch of open air for the very first time in its long existence. It is, in its own geological way, a kind of birth. The same molten material stepping for the first time into a world it can finally be seen and touched and measured directly, rather than only inferred from a great and cautious distance. This difference in behavior, thick paste below the surface, flowing stream above it, comes largely from the sudden release of pressure and the escape of dissolved gas that we spent time with in our exploration of eruptions, freed at last from that confinement. Lava can move in ways magma never could while still buried deep below. And it is this movement, this flowing, spreading, cooling journey across the surface that gives rise to some of the most striking textures found anywhere on Earth. Consider first the two most well-known and widely recognized surface textures that fluid lava can take as it cools. Textures that carry names borrowed from the Hawaiian language, where volcanic activity has long been a familiar part of daily life. The first is called puhoihoi, and it describes lava that cools slowly into a smooth, ropey, almost fabric-like surface, wrinkled and folded the way a heavy blanket might fold and wrinkle when pushed gently across a table. This texture forms when lava is unusually fluid and moving at a gentle, unhurried pace, its outer surface cooling and forming a thin, flexible skin, while the still molten material underneath continues to flow steadily forward, dragging and folding that thin skin into smooth, undulating ropes as it goes. The second texture could hardly look more different from the first, despite forming from lava of a very similar underlying chemical character. This is called awe, a name said to echo the soft crunching sound one might make walking barefoot across its surface, and it describes lava that cools into a rough, jagged, almost impossibly sharp landscape of broken, clinker-like fragments where puhoihoi forms from lava, moving gently and evenly across open ground. Ah tends to form when lava moves more quickly or has cooled slightly more before erupting, thickening it just enough that its outer surface cannot simply fold smoothly as it moves. Instead, that surface breaks apart entirely as the still molten interior continues pushing steadily forward beneath it, shattering the cooling crust into countless rough fragments that tumble and pile as the flow advances, leaving behind a landscape that looks, from a distance, almost like a frozen sea of broken black glass. It is a strange and lovely fact that the very same lava from the very same eruption can sometimes produce both textures within a single flow. Smooth puhoihoi near its source, where the lava moves gently and retains more heat, gradually transitioning into rougher awe further downstream as it cools slightly, thickens slightly, and begins to move with just enough extra resistance to shatter rather than fold. Watching such a transition unfold, were you able to observe it safely from a comfortable distance, would feel a little like watching a calm conversation slowly grow more strained the further it travels from its beginning. The same underlying warmth still present, but expressed now with a rougher, more effortful texture than it carried at its gentle start. There is a third texture worth a brief mention, quieter and stranger than the other two, that forms not in open air at all, but deep beneath the surface of the sea when lava erupts underwater, meeting cold seawater rather than open sky. It cools with tremendous speed, far faster than it ever could on land. And this rapid chilling causes it to form small, rounded, pillow-shaped lobes, rather than any of the ropey or jagged textures we have walked through tonight. Each pillow forms its own thin, quenched skin almost instantly, while more molten material breaks through that skin to form the next pillow just alongside it, gradually building an entire underwater landscape of these smooth, stacked forms. One gently rounded shape after another. A texture we will return to when our journey later carries us beneath the waves, beneath the smooth surface of a Pompeii flow. Something else remarkable can occur. One of the quieter architectural wonders of the volcanic world. As the outer skin of a slow lava flow cools and hardens, it can form a solid roof over the still molten river, continuing to flow beneath it. Insulated now from the cooling air above, this insulation allows the lava underneath to travel far greater distances while remaining hot and fluid than it otherwise could if left fully exposed, sometimes carrying molten rock many miles from its source, hidden the entire way beneath a hardened ceiling of its own making. Inside such a tube, temperatures can remain remarkably close to those found at the very source of the eruption, since the hardened roof above acts much like the walls of a well-insulated home, holding heat inside and slowing its loss to the cooler world outside almost entirely when the eruption finally ends and the last of the molten material drains away, leaving the tube empty behind it. What remains is a long, hollow tunnel, a lava tube, sometimes tall enough to walk through upright, wandering beneath the surface in the exact winding path the hidden river once followed. fossil of movement rather than a fossil of any living thing in places where these tubes have since cooled fully and become stable. They sometimes host their own quiet, sunless little worlds, delicate mineral formations, growing slowly on their ceilings and floors over many centuries, and occasionally small creatures that have adapted to a life spent entirely without daylight, distant descendants of surface dwellers that found their way underground long ago and never needed to leave, cooling itself. It turns out shapes far more than surface texture alone. It also shapes what is happening deep within the rock at a scale far too small for any eye to see unaided. The size and arrangement of the mineral crystals forming as the molten material solidifies when magma cools slowly deep underground, sealed away from the rapid chill of open air. Its minerals have ample time to organize themselves into large, well-formed crystals, growing steadily over months or years or even centuries, undisturbed, patient, thorough. Each mineral within the cooling magma tends to solidify in its own particular order, following the same kind of quiet sequence we touched on earlier when we spoke of partial melting, only now running in reverse. Certain minerals crystallizing first, while the surrounding material remains liquid a while longer, giving each crystal ample room and ample time to grow to a size a careful eye can easily observe. Rock that cools this slowly, far beneath the surface, is called intrusive or plutonic rock, and it tends to have a coarse, visibly crystalline texture, individual mineral grains large enough to see and even distinguish from one another with the naked eye. Granite being perhaps the most familiar example most people have encountered, often polished smooth in kitchen countertops, without a single thought given to the patient underground centuries required to grow it. Such rock never actually erupts at all in its original form. It remains buried, cooling in place, and only becomes visible to us many years later, once the softer rock that once surrounded it has slowly worn away above it, revealing at last a crystalline structure that finished forming long before it ever felt open air upon its surface, lava by contrast, cools far more quickly once it reaches the surface, sometimes within mere minutes, rarely more than a few years, even for a very thick flow. This rapid cooling gives crystals little to no time to grow to any meaningful size. The result is rock with a far finer texture, sometimes so fine the individual mineral grains cannot be distinguished at all without magnification. And in the most extreme cases, where cooling happens with true and sudden speed, no crystals form at all. Instead, the molten material solidifies directly into a natural glass, its atoms frozen in place before they ever had the chance to organize themselves into any orderly crystalline pattern whatsoever. Caught mid-arrangement, the way a held breath catches a moment before it can finish becoming a sigh. This volcanic glass, black and smooth, and often startlingly sharp along any broken edge. We will spend more time with directly in the chapter that follows this one. There is a particular kind of patience worth noticing in this relationship between time and texture, a patience worth sitting with a moment longer before we move on. The slower something cools, the more organized, the more crystalline, the more deliberately structured it becomes. The faster something cools, the more its structure is left frozen mid-thought, caught in whatever arrangement it happened to hold in that final, rushed instant before movement stopped entirely. Neither outcome is better or worse than the other. They are simply different answers to the same quiet question of how much time was available for settling into shape. Perhaps there is something worth carrying from this into your own rest tonight. Some nights, sleep arrives slowly, patiently, allowing thoughts to settle and organize themselves gradually into something calm and well-formed. The way deep, unhurried cooling allows a crystal to grow large and clear, each thought given ample room to find its own natural place before the next one arrives. Other nights, rest arrives more quickly, more suddenly, catching your thoughts mid-motion and settling them all at once into stillness, smooth and glassy, rather than slowly structured. an outcome for having arrived so quickly. There is no wrong way for this evening's rest to arrive. Whether it comes slowly, layer by patient layer, or arrives all at once, smooth and sudden and complete, either path leads, in the end, to the very same quiet stillness. Let yourself cool now, however your own rhythm prefers tonight, slow and crystalline, or swift and smooth, and settle without any need to choose which way is right, into whatever shape of rest comes most naturally to you. Every volcano, in its own time, leaves something behind. Long after an eruption has quieted, long after the glowing rivers of lava have cooled, and the last drifting ash has settled softly to the ground, stone remains, patient and solid, holding within its texture and its weight the entire quiet story of how it came to be. Tonight, let us hold 3 of these quiet stones in our hands, one at a time, unhurried, and let each one tell us, softly, something about the particular way it was born. The first stone is obsidian, and we touched briefly on its origin already in our earlier exploration of cooling and crystal growth. Obsidian is what happens when lava cools with such tremendous speed that its minerals never have the chance to arrange themselves into any crystal structure at all. Instead, the molten material solidifies exactly as it was in its final liquid instant. Atoms frozen mid-motion, caught in a kind of suspended stillness, rather than settled into any orderly pattern. The result is a natural glass, deep black in most cases, though sometimes carrying faint streaks of brown, or a subtle sheen of gold or silver, where trace minerals or tiny trapped bubbles catch the light in unusual ways. Hold a piece of obsidian in your palm, and it feels cool and smooth in a way quite different from ordinary stone, almost like touching the surface of still, dark water that has, somehow, forgotten how to move. Its surface, where broken, curves in soft, sweeping arcs rather than breaking along flat plains, the way most crystalline rock does. This particular kind of fracture is called conchoidal, a word that simply means shell-like. And if you look closely at a broken edge of obsidian, you will notice it does indeed curve and ripple the way the inside of a seashell often does. Smooth ridge after smooth ridge, radiating outward from wherever the stone was struck. There is a quiet reason this particular kind of fracture occurs, and it traces directly back to the absence of any crystal structure at all. Ordinary crystalline rock tends to break along the flat internal planes, where its many small mineral grains meet one another, the way a tiled floor might crack cleanly along the seams between its tiles, rather than through the tiles themselves. Glass has no such seams to follow. Without any internal structure to guide a fracture, obsidian simply breaks along whichever curved path allows stress to release most smoothly and evenly through the material, producing the same gentle shell-like curve again and again, regardless of where or how forcefully the stone happens to be struck. Obsidian rarely forms in thick, isolated masses on its own, since a large body of lava, insulated by its own bulk, tends to cool slowly enough to allow at least some crystal growth somewhere within it. Instead, true obsidian tends to appear along the thin outer edges of certain lava flows, or within narrow veins where especially fast cooling was possible. A delicate glassy skin wrapped around a slower, more ordinary crystalline interior, finding a substantial deposit of obsidian, thick enough to work easily by hand, has always required a particular combination of especially silica-rich lava and an especially rapid, especially thorough chilling, a combination the earth offers only in certain fortunate places. This same conchoidal fracture, curving so predictably and producing edges so remarkably fine, is part of why obsidian has held such a quiet, steady place in human history for so many thousands of years, long before metal was ever shaped into a fine blade. People across many different parts of the world discovered that a carefully struck piece of obsidian could produce an edge sharper, in a very literal sense, than most steel manufactured even today. We will return to this old, patient relationship between people and volcanic stone later, in our long journey together. But for now, it is enough simply to admire the strange elegance of a stone that cooled too quickly to crystallize, and in doing so became something capable of an edge so fine it could hardly be improved upon by any hand. The second stone could not feel more different resting quietly in your palm, despite being born from a strikingly similar restless origin deep within the earth. This is pumice, and where obsidian is dense and smooth and heavy for its size, pumice is astonishingly light, riddled throughout with countless tiny air pockets, so light, in fact, that many varieties of pumice will float easily on water, resting on the surface the way a small piece of cork might, rather than sinking the way stone almost always does. Pumice forms during especially explosive eruptions, the kind we explored when we followed gas-rich magma tearing itself apart as it rushed toward the surface, as that magma, thick and heavily saturated with dissolved gas, suddenly loses pressure and is hurled into the open air. The gas within it expands with tremendous speed, forming countless tiny bubbles throughout the material, just as it also begins to cool and harden almost instantly. Because this cooling happens so quickly, those bubbles become trapped in place before they have any chance to escape or collapse, frozen permanently within the hardening stone, leaving behind a rock that is, by both weight and volume, made up largely of empty space. It is, in a strange way, less a solid stone than a delicate stone-colored foam, holding its shape admirably despite being composed mostly of air. It is worth pausing on just how remarkable it is that pumice floats at all, since stone, in almost every other circumstance, sinks without hesitation the moment it touches water. Pumice manages this small, quiet defiance simply because so much of its total volume is occupied by trapped air rather than solid mineral material, lowering its overall density below that of water itself. The same simple principle that allows a heavy ship built from dense steel to float, provided enough of its total volume is given over to empty, air-filled space, given enough time submerged in sea eventually seep into these tiny pockets, filling them slowly and causing even pumice to sink at last. Though this process can take a surprisingly long while, and pieces of pumice have been known to drift for great distances across open ocean, carried by currents for months or even years, occasionally arriving on shores impossibly far from the eruption that first created them, quiet travelers bearing no memory of the journey they had taken. This same frothy, air-filled structure gives pumice a rough, almost sandpaper-like texture along its surface, since each tiny bubble, once exposed by fracture or wear, leaves behind a small hollow pit rather than a smooth face. This texture has made pumice useful to people for a very long, quiet stretch of history as well. Employed gently as a natural abrasive for smoothing rough skin or polishing delicate surfaces. Its countless tiny air pockets, giving it just enough gentle bite to soften what it touches without ever scratching too deeply. There is something worth noticing side by side in these first two very different stones. Obsidian and pumice can form from remarkably similar magma, sometimes even from the very same eruption, and yet one becomes dense, heavy, and glassy smooth, while the other becomes light, airy, and rough throughout. The difference between them comes down almost entirely to how much gas the original magma carried, and how quickly it was able to escape as the material cooled. Where gas escapes gently, or was never abundant to begin with, dense, glassy obsidian tends to form. Where gas is abundant, and cooling happens with true explosive speed, trapping that gas permanently within countless tiny bubbles. The frothy lightness of pumice results. Instead, the third stone, our final companion for tonight, is basalt, and it may be, of all volcanic stones, the most common substance on the entire surface of our planet, quietly present in far greater quantity than either of the other two stones we have held tonight. Even though it rarely receives quite the same attention or admiration, basalt forms from lava that is thin, fluid, and relatively low in the same mineral, silica, that we discussed briefly when we explored the gentle, wide slopes of shield volcanoes. This is, in fact, precisely the lava that builds those wide, gentle shields. And it is also the very same lava that quietly forms the floor of nearly every ocean on Earth, cooling along the hidden ridges where new seafloor is endlessly created, spreading outward in vast, thin sheets far beneath the waves, where almost no one will ever see it directly. Basalt tends to be dark, dense, and fine-grained. Its individual mineral crystals, typically too small to see without magnification, since it cools quickly enough at the surface to prevent large crystal growth. Yet, not nearly as suddenly as the lava that forms glassy obsidian, one of the loveliest patterns basalt can form, appears when a thick, slow-cooling flow contracts evenly as it hardens, cracking into long, strikingly regular columns, usually with 5 or 6 flat sides, standing side by side like a vast collection of stone pillars, packed together as neatly as the cells of a honeycomb. This happens because basalt, as it cools from the top and bottom of a flow inward, shrinks very slightly and very evenly. And rock, when it shrinks evenly across a flat sheet, tends to crack in this same repeating hexagonal pattern. The most efficient way for a contracting surface to relieve its tension without wasted, uneven stress. It is the very same principle in miniature that causes a drying layer of mud to crack into a similar network of roughly hexagonal plates, each shape emerging not from any plan or design, but simply from the most efficient way. A shrinking surface can relieve stress evenly in every direction at once, given enough time and enough patience. These cooling cracks can travel from the outer surface of a flow completely into its depths, growing slowly downward or upward as the cooling front itself advances, leaving behind towering fields of naturally geometric stone columns, so regular in appearance that early observers sometimes assumed they must have been carefully carved by human hands, rather than shaped entirely by the slow, even patience of cooling rock. Such formations can stand for many thousands of years once exposed. their symmetrical faces gradually weathering and softening at the edges, though their essential geometric character remains remarkably legible even after the passage of an immense stretch of time. 3 stones, then, born from the very same restless source deep within the earth, and yet each one carrying its own separate temperament forward into permanence, each one telling its story a little differently, obsidian, quick and glassy and sharp, holding the memory of a sudden, total stillness. Pumice, light and frothy, and full of trapped breath, holding the memory of gas escaping all at once into open air, basalt, patient and dense and dark, holding the memory of slow, steady, even cooling, sometimes even cracking itself gently into neat and orderly columns as it settles into its final permanent shape. As you rest here tonight, you might consider which of these 3 stones your own evening most resembles. Perhaps your thoughts tonight are quick and smooth, settling almost instantly into stillness the way obsidian does, curving gently rather than breaking sharply. Perhaps they feel light and full of small trapped breaths, still settling gradually, the way pumice slowly stops drifting on the surface of calm water after a long, unhurried journey. Or perhaps your rest tonight will be patient and even cooling slowly and evenly, gently cracking itself into its own comfortable, orderly shape the way a wide basalt flow settles into columns over long stretches of undisturbed time. There is no need to choose. Every stone in the end finds its own true and lasting stillness, and so tonight will you. We touched some time ago on a curious kind of volcano that forms nowhere near the edge of any tectonic plate, rising instead from the quiet middle of a plate's interior, fed by heat that seems to come from somewhere far deeper than the ordinary boundaries we traced together earlier. Tonight, let us slow down and sit with this mystery properly, following it all the way down to its source and all the way out to one of the most beautiful and improbable chains of islands found anywhere on our planet, deep beneath the moving plates of the Earth's crust, far below even even the churning currents of the upper mantle. There exist certain narrow columns of unusually hot material, rising slowly from somewhere close to the boundary between the mantle and the core itself. These are called mantle plumes, and they behave something like the narrow, rising thread of warm water you might notice near the bottom of a pot, only just beginning to heat. A single column of gentle upward motion within a much larger, calmer body, unlike the great restless currents of the mantle that carry entire tectonic plates slowly across the surface of the earth. These plumes appear to remain remarkably fixed in place, anchored deep below, largely unmoved by the drifting plates gliding along far above them. The heat carried within these plumes is thought to originate from very near the boundary, where the rocky mantle meets the far hotter, largely metallic core beneath it. A boundary where temperatures can differ so dramatically from one side to the other that heat is, in a sense, always eager to find some narrow path upward, rather than warming the entire mantle evenly. This heat appears to concentrate itself into these narrow rising columns, threading upward through thousands of miles of solid, slow-moving rock over a span of time, so long it barely resembles anything we would ordinarily call travel at all, more a kind of patient, continuous seeping than any deliberate journey. By the time this deep heat finally nears the underside of the crust, it has been rising slowly and steadily for longer than most mountain ranges on the surface above have existed at all. This fixed quality is precisely what makes hot spots so quietly strange and so quietly beautiful once you begin to trace their pattern. Imagine holding a candle steady beneath a sheet of paper and slowly dragging that paper across the flame. The candle itself never moves, but the paper passing above it is scorched again and again in a line, a new small burn mark appearing wherever the flame happens to meet fresh paper, while the older burn marks left behind as the paper continues to move, gradually cool and drift further and further from the heat that first created them. This is, in essence, precisely what happens above a mantle plume. only the paper in this case is an entire tectonic plate, and the burn marks it carries away are not small scorched circles, but towering volcanic mountains, some rising thousands of feet above the surrounding seafloor before their fires finally quiet, and their long, slow drift away from the flame truly begins. The heat remains fixed. The plate above it slowly drifts, and wherever that fixed column of heat happens to meet the plate at any given moment, a new volcano begins to rise. Nowhere on Earth demonstrates this pattern more clearly or more beautifully than the long chain of islands and underwater mountains stretching across a vast reach of the Pacific Ocean, of which the Hawaiian Islands are the most famous and most recently formed. The Pacific Plate, like all tectonic plates, drifts slowly across the surface of the Earth, carrying everything resting upon it along for the same unhurried ride. Deep beneath this drifting plate, in one particular fixed location, a mantle plume has been quietly, patiently rising for tens of millions of years, feeding volcano after volcano as the plate above it continues its slow northwestward journey. Each time the plate has drifted just far enough, the plume beneath it finds itself beneath fresh, unweakened crust once again, and a brand new volcano begins its long, patient rise from the ocean floor. The result of this process, repeated countless times across an almost unimaginable stretch of geological time, is not a single island, but an entire chain, stretching in a long, gently curving line across thousands of miles of open ocean. The islands nearest the still active hotspot at the southeastern end of this chain are the youngest, tallest, and most volcanically alive, moving northwestward along the chain. Island after island grows progressively older, quieter, and more heavily worn by rain and wind, and the patient erosion of countless centuries, until eventually, far enough from the heat that once built them, these former volcanic peaks sink entirely beneath the waves, continuing on as submerged seamounts, their volcanic fires long extinguished, carried along now simply as passengers on a plate still slowly drifting toward the far distant edge of the ocean it will eventually disappear beneath. This slow aging follows its own gentle, predictable sequence, worth walking through unhurried. A young island, freshly built and still fed by the hot spot beneath it, stands tall and steep, its volcanic slopes bare or only lightly covered in new growth as the plate carries that island slowly away from the heat that built it. Its volcanoes fall quiet one by one, and rain and wind begin the long, patient work of softening its once sharp edges, carving valleys, rounding ridgelines, gradually wearing the island down, even as coral, drawn to the warm, shallow waters surrounding it, begins building its own quiet structures along the island's edges. Given enough time, the island itself may erode away almost entirely, sinking slowly beneath the waves as its foundation cools and settles, while the ring of coral that grew patiently around its shores continues building upward at roughly the same unhurried pace the island sinks, leaving behind, eventually, nothing of the original volcano at all, only a graceful ring of living coral encircling a calm lagoon where a tall volcanic peak once stood, a quiet monument built by living things to a mountain that no longer exists. The big island, the youngest and largest in this present chain, sits directly above the hot spot even now. And it is here that we find some of the most active shield volcanoes anywhere in the entire world, rising in the same broad, gentle profile we explored earlier, built from countless flows of the same thin, fluid lava that spreads so easily and so far before finally cooling into new stone. These enormous shield volcanoes, though they may not always look particularly tall when measured only from the waterline, are in fact, when measured properly from the ocean floor upon which they truly rest, among the tallest mountains found anywhere on earth, their true height simply hidden for the most part beneath the surrounding sea. Building a single one of these towering shields has required an almost unfathomable amount of patient, repeated effort from the hot spot below, countless individual eruptions, each contributing only a thin new layer of hardened lava, stacked one atop another continuous activity, gradually raising the ocean floor itself into the enormous mountain that eventually broke the surface of the sea. And even now, with the island already standing tall and green and inhabited, that same slow work continues quietly on several of its flanks. Fresh lava still occasionally reaching the coast and adding layer by careful layer a small measure of new land to an island that has, in truth, never once stopped growing since the very day it first began, and the story does not end even there. A short distance to the southeast of the big island, entirely hidden beneath the waves, a new volcano is already quietly rising, patiently building itself upward from the ocean floor, exactly as every island in this long chain once did before it broke the surface. This underwater volcano will not become visible land for a great many thousands of years yet, but it is already, in a very real sense, the next island in this ancient, ongoing chain, already following the same patient hotspot that built every island that came before it, simply waiting its turn, far beneath the surface, for the slow drift of the plate above to carry it, eventually into position for the fires below, to finish what they have already so patiently begun. Its summit still lies a considerable distance beneath the surface, and countless further eruptions will be needed, stacking layer upon patient layer, exactly as its predecessors did, before it ever rises high enough to greet open air for the very first time. There is something worth sitting with quietly in this entire long, unhurried pattern. The hot spot itself never moves and never seems to tire, sending its patient warmth upward in the very same place for tens of millions of years without pause or interruption. It is the world above it, the vast drifting plate that carries everything else along on its slow journey. Island after island, rising, aging, and finally settling beneath the waves, while the source of their creation remains the entire time exactly where it has always quietly been. This entire elegant pattern, fixed heat below and drifting crust above, was not always understood the way we understand it tonight. For a long while, the steady progression of island ages along this chain puzzled those who studied it, until careful measurements of the rock itself, comparing the age of each island against its distance from the still active hotspot at the chain's southeastern end, revealed a remarkably tidy relationship. The islands grew steadily older the further one traveled from the present hotspot, at a rate matching almost precisely the slow, measurable drift of the Pacific plate itself. It was this quiet correspondence, age increasing in careful step with distance, that finally confirmed what had long been suspected, that these islands were not separate, unrelated events at all, but a single continuous record, written patiently across thousands of miles and tens of millions of years, of one fixed source of heat and one slowly drifting plate passing steadily above it. It is worth noting, too, that Hawaii is far from the only place on Earth where this quiet pattern unfolds. Similar hotspot chains can be found beneath other oceans, and even beneath continents themselves, tracing their own long, patient lines across the surface of the Earth as their own particular plates drift slowly overhead, each one following its own unhurried pace, some faster, some slower, depending entirely on how quickly the plate above happens to be moving. Each one tells a slightly different version of the very same story. Fixed heat below, drifting crust above, and a long trail of aging volcanic peaks, marking the exact path that crust has followed across an almost unimaginable stretch of deep time. Perhaps there is something quietly comforting in this image as you rest here tonight. Somewhere deep and steady and entirely unhurried, a source of warmth has been rising in the very same place for longer than there have been mountains to receive it. Patient and constant regardless of how much drifts and shifts and changes in the world above it. You do not need to chase that kind of stillness tonight. You need only drift gently, the way an island drifts along an ancient plate, carried slowly away from the business of the day and toward the quiet, settled stillness that waits patiently for you at the end of that unhurried journey. Let yourself drift drift now, unhurried and steady, the way the whole wide floor of the ocean drifts above its own deep and constant warmth, carrying you gently, without any need to hurry, toward a rest as patient and unshaken as the fire that has waited quietly beneath the sea for longer than any island has stood above it. There is a certain island resting quietly in the cold northern reaches of the Atlantic Ocean that manages to hold two entirely different kinds of volcanic geography within the very same modest stretch of land. We have walked separately through both of these patterns already in our journey together. The long hidden ridge where plates gently pull apart beneath the sea, and the fixed, patient hotspot rising steadily from somewhere far below. Iceland is the rare and beautiful place where both of these stories happen to overlap, rising together into the very same quiet island. And tonight we will sit with that overlap slowly, unhurried, along with the second, equally remarkable ingredient that makes Iceland so entirely its own. The deep, old ice that has shaped so much of what this island has quietly become over countless patient centuries. We spoke some time ago of the mid-Atlantic ridge, that vast hidden mountain range winding down the entire length of the ocean floor, marking the place where two great plates slowly drift apart from one another, allowing warm material to rise gently and fill the widening gap between them. Almost the entirety of this long ridge lies far beneath the waves, invisible to anyone standing quietly on either shore of the ocean it divides. But in one particular place, that hidden ridge does something it does nowhere else on the entire earth in quite the same remarkable way. It rises high enough to break the surface of the sea entirely, standing openly in the cold northern air, rather than remaining hidden beneath the sea. And this one single remarkable exception found anywhere is Iceland itself. The reason for this exception traces back directly to the very same hotspot geography we explored just before this present chapter began. Beneath Iceland, in addition to the ordinary volcanic activity produced by two plates gently separating from one another, there also rises one of the Earth's own patient mantle plumes, feeding extra warmth and extra material into precisely the same place where the ridge already runs, where most of the mid-Atlantic ridge receives only the modest, steady supply of magma typical of any ordinary divergent boundary. Iceland receives that same steady supply, plus a considerable additional gift from the hotspot rising beneath it. And this extra abundance of rising material is precisely what has allowed the ridge, in this one fortunate location, to build itself high enough to finally break through the surface of the sea and stand as visible land because of this doubled source of volcanic material. Iceland is almost entirely built from the same dark, fluid basalt we spent time with earlier, layer upon countless layer of hardened lava flows, stacked across many millions of years. The island itself, essentially, a very tall, very wide, very patient accumulation of exactly the same volcanic stone that quietly forms the floor of every ocean on Earth. Only here, in this one place, allowed to rise high enough to greet open sky. This accumulation did not happen quickly, nor did it happen evenly across the entire island all at once. Some regions have been continuously active for the entire span of the island's existence, building thick, tall stacks of overlapping lava flows, many miles deep in places, while other regions, further from the most persistent volcanic activity, have grown far more slowly, receiving only occasional contributions across the same long stretch of time. The island's landscape, uneven and varied as it moves from region to region, quietly records this uneven history. Tall volcanic ridges standing near the most persistently active zones, gentler and older terrain spreading outward toward the island's quieter edges and running directly through the middle of this entire island, visible in a way found almost nowhere else on the planet, lies the very seam where the two plates are slowly separating. Standing in certain parts of Iceland, a person can, in a very literal sense, stand with one foot resting upon one tectonic plate and the other foot resting an entirely different one, the widening gap between them growing by roughly the same small distance every year that it does anywhere else along the ridge, only here made visible, walkable, entirely present, rather than hidden beneath miles of dark and silent ocean. This visible seam runs through a landscape of long fissures and cracks, some narrow enough to step across without much thought, others wide enough to hold small lakes of startlingly clear water within their depths, each one a small physical record of the same slow pulling apart happening everywhere else along the hidden ridge. Only here, unusually, open to direct observation, rather than requiring careful instruments lowered into the deep, dark sea. Walking through such a landscape, it is difficult not to feel, in some small, quiet way, the true scale of the forces we have spent this entire journey exploring. Ordinarily so vast and so slow, they remain entirely invisible to any single human life. And yet here, briefly, made walkable, touchable, almost intimate in their nearness. This alone would make Iceland a remarkable place in the story we have been following together. But Iceland carries one more ingredient, entirely its own, that gives the island its particular character, an ingredient found in its very name. Iceland sits far enough north and cold enough throughout much of the year that substantial glaciers have formed and persisted across considerable portions of its volcanic terrain. Thick sheets of ancient compressed snow resting directly atop many of the very same volcanoes we have just described. Some of these ice caps hundreds of feet thick in their deepest sections, pressing down upon the fire beneath them with a slow, patient weight of their own. And where fire meets ice in this particular way, something entirely unique unfolds, a relationship found in only a small handful of places anywhere on Earth. When a volcano erupts beneath a thick glacier, the heat it releases does not simply rise into open air the way it would on ordinary ground. Instead, that heat first meets a great mass of solid ice resting directly above it, and the ice, rather than resisting that heat indefinitely, begins to melt considerable speed. An enormous quantity of meltwater, accumulating rapidly within a cavity carved directly into the base of the glacier by the rising heat below. This cavity grows steadily as the eruption continues, the ice above it forming a kind of temporary ceiling, holding back, for a time, a body of water that grows larger and heavier with every passing hour. The eruption below continues its quiet work. For a time, this meltwater may remain trapped, held back by the surrounding ice like water gathering behind a natural dam, formed entirely of frozen water rather than stone or earth. A dam with no engineer to reinforce it, and no gate to release its pressure gradually, but eventually, as the meltwater continues to accumulate. The pressure it exerts against its icy container grows too great to contain any longer, and the dam gives way all at once, often along some hidden channel beneath the glacier's edge, releasing an enormous, sudden flood that surges out from beneath the glacier and races across the land below with startling speed and force, carrying with it not only water, but broken ice, volcanic ash, and fragments of stone swept along in its powerful current. These sudden floods are known in the language of the island itself as Yellowstone, and they represent one of the most distinctive natural events found anywhere on Earth. A flood born not from rainfall or storm, but from fire meeting ice deep beneath a glacier's own quiet weight. Rivers that might ordinarily carry only a modest, gentle flow can, within the space of a few short hours, swell to carry a volume of water rivaling some of the largest rivers found anywhere on the planet, before receding again just as quickly once the trapped reservoir beneath the ice has fully emptied itself. Communities living downstream from such glaciers have, over many generations, learned to watch for the quiet warning signs that typically precede such a flood. Changes in the color or temperature of glacial rivers, faint tremors felt deep underfoot, small shifts that speak of heat gathering somewhere far beneath the ice, long before any visible flood ever begins its sudden race toward the sea. Eruptions occurring beneath thick ice can also produce a landform found in very few other places. A flat-topped mountain called a tuya, distinctly different in shape from any of the volcanic shapes we explored earlier in our journey when lava erupts beneath a glacier. It does not spread freely the way it would in open air, since the surrounding ice constrains it, cooling it rapidly and shattering much of it into fragmented, glassy rubble, rather than allowing it to flow in smooth, continuous sheets. This produces a steep-sided mound built largely from this shattered material, quite unlike an ordinary shield or stratovolcano. Its slopes composed not of smooth, hardened lava, but of countless broken glassy fragments, cemented gradually together as the eruption continues, and further material piles atop what came before. But if the eruption continues long enough, and enough material accumulates, the rising volcano may eventually breach the surface of the ice entirely, pushing at last above the level of the surrounding glacier. Once it does, freed from the ice's confining pressure, its lava begins to behave in the ordinary way we are already familiar with, flowing freely across open air and cooling into a flat cap resting atop the steep, ice-shaped mound below, spreading outward in thin, gentle sheets, the same way any exposed lava would, rather than shattering and piling as it had while still confined beneath the ice. The result, once the surrounding glacier has long since melted away and left the mountain fully exposed to open sky, is a landform shaped almost like a great flat-topped table. Its lower slopes recording a story of confinement beneath ancient ice, its flat upper cap recording the moment it finally broke free into open air, standing before such a mountain today, long after the glacier that shaped its base has vanished entirely, is a little like reading a mountain's own quiet autobiography, written directly into its shape. Each section of slope and cap marking a distinct chapter in its slow relationship with the ice that once surrounded it. Iceland's volcanoes, then, carry within their very shape a quiet record of the ice that has shaped them alongside the fire that built them. A partnership between between two forces that might, on the surface, seem like natural opposites, yet have worked together across countless centuries to build an island unlike any other found on the whole of the earth. Fire rising patiently from deep below, meeting ice, resting patiently from above, each one shaping the other in return, neither one entirely overpowering the other, both leaving their mark on the very same quiet landscape. There is something worth carrying from this into your own rest tonight. Something about the way two very different forces, warmth and cold, urgency and stillness, need not stand entirely opposed to one another. Perhaps your own evening holds a little of both as well. Some part of you still warm and active from the day now ending. Some part of you already cool and settling toward quiet. There is no need to choose only one. Let them meet gently. The way fire meets ice beneath a patient northern glacier, each one softening the other's edges, neither one shattering nor melting the other away entirely, simply meeting quietly until what remains is something calm and settled and entirely its own, neither purely one nor purely the other, simply ready at last for rest. Let that quiet meeting happen now. Warmth and coolness settling gently together, within you the way they have settled together for so long beneath that distant northern island, and rest there patiently, exactly as you are. There are certain places in the world where time seems to have simply paused, mid-gesture, mid-conversation, mid-ordinary afternoon, and stayed that way for nearly 2,000 years. Tonight, we visit two such places, quiet towns resting along the warm coast of southern Italy, towns that once lived entirely ordinary lives beneath the slopes of a nearby mountain, until the day that mountain, without any warning, anyone at the time could fully recognize, changed everything, and in doing so, preserved everything in a way almost nothing else in the whole of human history ever has. We will spend more time with the mountain itself, Vesuvius, and its long history across many centuries, later in our journey together, when we walk through its own particular story in fuller detail. Tonight, our attention rests instead on the towns themselves, Pompeii and Herculaneum, and on the strange, gentle gift, that catastrophe, in this one particular case, left quietly behind for those who would come many centuries later, before that fateful day. These were simply towns, unremarkable in the way most towns are unremarkable, filled with people going about entirely ordinary lives. Bakers rose early to fire their ovens, the smell of warm bread drifting quietly through narrow streets before most of the town had even woken. Merchants arranged their goods along narrow stone streets, calling gently to passers-by, adjusting their displays of pottery or cloth or fresh produce brought in from the surrounding countryside that same morning. Families gathered in courtyards shaded by grapevines. Children ran laughing through alleyways, chasing one another between deliveries and errands. And along the walls of countless homes, painters had left behind bright, cheerful frescoes, scenes of gardens and gods, and everyday pleasures, decorating the walls the way any of us might hang a favorite picture today, chosen simply because it brought some small daily comfort to whoever lived within those rooms. It is worth pausing for a moment on just how thoroughly ordinary this all was. No one waking that particular morning imagined themselves living through anything worth remembering at all. It was, for nearly everyone in these two towns, simply another day among countless others, indistinguishable in its beginning from the many mornings that had come before it, and the many more that everyone assumed would surely follow when the mountain above these towns finally released the pressure it had been patiently gathering. It did so in the manner we explored when we walked through the anatomy of an eruption, ash and pumice rising high into the sky in a great dark column, only to begin, some hours later, drifting steadily back down over the towns below, quiet and unhurried at first, the way the first flakes of an early winter snow might drift down over a town, not yet aware of how deep that snow will eventually settle. In Pompeii, this material arrived gradually at first, falling as a slow, continuous rain of light volcanic debris. giving many residents ample time to gather what they could and leave the town behind, while others, for reasons history can no longer fully recover, chose to remain a while longer in the homes and streets they had always known so well. Over the following day, this fall of ash and pumice continued, layer settling upon layer, gradually burying the town beneath a blanket that grew, in places, taller than a person standing upright, roofs strained, and eventually gave way beneath the accumulating weight. The same way freshly fallen snow can eventually overwhelm a roof never built to hold such an unexpected burden. Streets disappeared entirely beneath the settling debris. Doorways vanished. Courtyards filled slowly from the ground upward, until even the tallest surrounding walls stood only barely visible above the pale, settling surface. And when at last the fall subsided and the sky above slowly cleared, the town that had stood there only a day before was gone from view entirely, resting now beneath a deep, quiet layer of pale volcanic stone, as still and as silent as though it had simply been tucked gently beneath a thick, protective blanket and left undisturbed. It is this particular manner of burial, gradual, gentle in its own strange way, material settling softly rather than arriving all at once with overwhelming force, that left Pompeii in the condition we find it today, because the ash and pumice fell steadily rather than violently. Many structures remained remarkably intact beneath their new covering, walls still standing, floors still level, the layout of entire neighborhoods preserved almost precisely as they had been on the very last ordinary morning anyone there ever knew. Even the smallest, most fragile details survived this gentle process far better than anyone at the time could possibly have anticipated. Delicate garden plantings, leaving behind precise, root-shaped hollows within the hardened ash, later identified and even replanted by patient archaeologists eager to restore gardens to something resembling their original cheerful arrangement. Herculaneum, a smaller town resting closer to the mountain itself along the shore, experienced something rather different, rather than the slow, steady fall of ash and pumice that settled over Pompeii. Herculaneum was met instead by the swift, hot currents we explored earlier when we spoke of pyroclastic density flows, moving quickly down the mountain slopes and arriving with far greater speed than any falling ash could manage. This different manner of burial preserved the town in an entirely different way, sealing it beneath material that, upon settling, hardened into a dense, protective layer far more solid than the looser ash and pumice that covered its neighboring town, and preserving, remarkably, even delicate organic material that would ordinarily have decayed entirely within only a few short years. This heat carried within these swift currents, though considerable, passed through the town with such speed that many delicate materials were sealed away, and starved of the ordinary air and moisture that would otherwise have caused them to rot and crumble across the following many centuries in this strange protective sealing. Materials that almost never survive the ordinary passage of time found themselves preserved instead, held quietly still within their hardened covering for nearly 2,000 years, waiting patiently for the moment careful hands would finally uncover them once again. It is because of this particular kind of burial that archaeologists working in Herculaneum have discovered wooden furniture still holding its original shape, wooden roof beams still visible within collapsed structures, delicate wooden doors still hanging, faintly warped but recognizable within their original door frames, and even certain foods carbonized rather than decayed, offering a direct, tangible connection to the very last meals prepared in kitchens that had, until that single afternoon, functioned exactly as they always had for generations before. Scrolls of papyrus, kept quietly within one particular grand villa's private library, survived as well, blackened and impossibly fragile, yet still holding within their carbonized layers faint traces of the words once written upon them. Patient scholars today working with careful, painstaking methods to coax those ancient words gently back into legibility. After so very long spent in quiet, sealed darkness, both towns remained resting quietly beneath their respective coverings for many centuries, their existence gradually fading from active memory, even as farmers, entirely unaware, cultivated the fertile soil that had, over time, developed atop the buried towns below. The same rich volcanic ash we discussed earlier proving, once again, remarkably generous to the crops planted above it, grapevines and olive trees, rooting themselves unknowingly above rooftops and courtyards that no living person remembered. It was only much later, when careful excavation slowly began peeling back these accumulated layers, that the full and remarkable extent of what lay preserved beneath finally came, gradually and patiently, back into view among the most quietly moving discoveries made during this long process of excavation. Involves not objects at all, but empty space. As the soft ash and pumice settled over Pompeii, it gradually hardened around anything it surrounded, including, in certain tragic instances, the bodies of those residents who had not managed to leave in time. Over the following centuries, these bodies slowly decayed away entirely within the hardened ash, leaving behind precise, hollow voids in the exact shape they had occupied in their final moments. Folds of clothing and even facial expressions, sometimes preserved within the negative space left behind when archaeologists, many centuries later, discovered these hollow spaces and carefully filled them with plaster. The shapes that emerged captured, with startling and tender precision, the exact final postures of people who had lived and breathed in this town so very long ago. A quiet, dignified record of individual human presence, preserved not through any physical remnant of the body itself, but through the careful, patient shape that absence alone had left behind, walking through Pompeii today. A visitor encounters far more than simply preserved buildings and preserved absence. Entire bakeries stand with their round stone ovens still intact, some still holding the carbonized remains of the very last loaves ever placed inside small dark shapes that once rose warm and fragrant on an ordinary morning, like any other. Public bathhouses retain their original painted ceilings and mosaic floors. Patterns of small colored stone still arranged in the exact designs. Some careful craftsperson laid out many centuries before. Tiny fish and dolphins and geometric borders picked out tile by patient tile. Fast food counters of all things line certain streets. Wide stone surfaces set with round holes that once held pots of soup or wine, meant to serve residents too busy or too poor to cook a full meal at home. An oddly familiar echo of a kind of convenience we might recognize easily even now. A quick, warm meal grabbed on the way to somewhere else entirely. Political messages scrawled directly onto walls in support of one candidate or another remain legible even today. Small, ordinary opinions from ordinary residents, never intended to last even a single generation, let alone very nearly 2,000 years elsewhere throughout the town. Simpler messages remain as well. A name carved idly into plaster. A small drawing left quietly by some unknown and unremembered hand. The same small, quiet impulse to leave some mark behind that people have carried with them across every single century since. There is something worth sitting with quietly and gently in all of this, as your own evening winds slowly toward its close. These towns were not remarkable in their own time for any particular reason. They were simply places where people lived. Ordinary lives filled with ordinary mornings, ordinary meals, ordinary conversations that seemed, at the time, hardly worth remembering at all. And yet, through the strange, gentle patience of settling ash, an entire ordinary world was preserved in such careful detail that we, so many centuries later, can walk quietly through its streets and feel, in some small way, how very close that distant morning still remains, how easily we might recognize ourselves in the small daily habits of people who lived and worked and rested so very long before us. Perhaps there is comfort in this as you rest tonight. The smallest, most unremarkable moments of an ordinary life. A loaf of bread rising in an oven, a fresco painted simply because it brought someone joy, a quiet afternoon shared beneath a shaded courtyard can hold within them a kind of quiet permanence, whether or not anyone at the time ever imagined they might last. Your own evening, however ordinary it may feel, is itself simply one more quiet layer settling gently into the long, patient record of a life lived. One calm, unremarkable moment at a time. No less worth having lived simply, because it will not itself be remembered by anyone many centuries from now. Let yourself settle now, the way soft ash settles gently over a quiet sleeping town, layer upon patient layer, until everything rests still and calm and safely held exactly as it is, ready for whatever quiet centuries may come next. Long before anyone understood magma chambers or tectonic plates, or the slow, patient chemistry of melting stone, people everywhere still needed some quiet way to make sense of the mountains that occasionally breathed fire into the sky above their homes tonight, rather than following heat and pressure and rising rock as before. Let us follow instead the quiet, old stories people told one another to explain what they saw. Stories passed gently down from one generation to the next long before any of us had words like magma or vent or eruption to reach for instead. It is worth noticing before we begin our own journey tonight just how similar many of these old stories turn out to be, even when told by people who lived entire oceans apart, who never once had any opportunity to share their tales with one another. Wherever there has been a mountain capable of fire, it seems people across the world have reached for the same quiet explanation that something alive, something with its own will and its own moods, must be resting within it. In ancient Rome, this presence was given the name Vulcan, a god associated with fire and with the forge, imagined as tending a great workshop deep beneath the earth, hammering and shaping metal with such vigor that sparks and smoke occasionally found their way up through the mountain above him. Roman tradition held that Vulcan crafted remarkable objects within this hidden workshop. Weapons and armor and delicate ornaments alike. Each strike of his hammer against glowing metal explaining, in the imagination of those who told his story, the rumbling and flashing that occasionally rose from the volcanic islands scattered near the southern coast of Italy. One such island in particular came to be so closely associated with this fiery workshop that its own name eventually became a general word for any similarly small volcanic island rising from the sea. A naming so successful that it has quietly outlived the specific story that first inspired it. The very word volcano descends directly from this old name, carried forward across many centuries of language until it settled quietly into the word we still use today for any fire-breathing mountain anywhere on earth. The Romans, in turn, had inherited much of this same idea from earlier Greek tradition, where a similar figure, Hephaestus, was imagined laboring at his own forge beneath a different mountain entirely. His hammer strikes, explaining the trembling and rumbling that sometimes rippled through the ground nearby. Hephaestus, in these older Greek tales, was often described as somewhat apart from the other gods, spending his days in quiet, focused labor rather than idle company. His workshop, a place of genuine craft and dedication rather than simple mischief or spectacle, a detail that lends his particular myth a gentler, more industrious character than many of the other stories told about the gods of that same tradition. Travel far across the world to the islands of Hawaii, and we find an entirely different story, told by people who could never have heard of Vulcan or Hephaestus, and yet arrived in their own way at a similarly personal explanation for the fire beneath their own feet. Here, the presence within the mountain is Pele, a goddess of volcanoes and fire, imagined not as a distant craftsman working quietly at a forge, but as a living, breathing, deeply present force, dwelling directly within the fiery heart of the very volcanoes we spent time with earlier in our journey. Traditional stories describe Pele as having traveled across the wider Pacific before finally settling within the volcanic heart of the Hawaiian Islands, digging her fiery home ever deeper with each new island she visited, until she came finally to rest within the youngest and most active island of the entire chain. The very same island where the hot spot we explored together continues its patient work even now. Peele's stories describe her as passionate and quick to feel, her moods reflected directly in the behavior of the mountains she inhabits. Calm and generous in gentler seasons, restless and dramatic in others, she is often described not as a distant, abstract force, but as someone capable of appearing directly among people, sometimes as an elderly woman walking a quiet roadside, sometimes as a young woman of striking presence, testing in these old tales the kindness and hospitality of those she happens to meet along her way. Hawaiian tradition holds deep respect for Peele even now, and many who live upon these islands continue to honor her with quiet offerings and careful, respectful acknowledgement whenever they find themselves near her volcanic home, leaving small gifts of flowers or food at the edge of her craters, a gesture of ongoing relationship rather than distant, one-time reverence. In Japan, the tallest and most revered mountain of all, itself a volcano resting quietly for many long centuries between periods of activity, has long been considered not merely a home for some separate divine presence, but sacred in its very form. Its perfectly symmetrical slopes, rising toward the sky, treated as a place worthy of pilgrimage and quiet reverence in its own right. This particular kind of reverence, honoring the mountain itself rather than some separate spirit imagined to dwell within it, reflects a somewhat different relationship than the traditions of Rome or Hawaii. One where the volcano's very shape and presence are treated as inherently sacred, requiring no additional divine tenet to justify the deep respect shown toward it. Countless generations have made the patient climb toward its summit not out of scientific curiosity, but out of genuine devotion, treating the ascent itself as a kind of spiritual practice, a slow deliberate journey towards something larger and older and steadier than any single human life. Traditional pilgrims would often begin this climb only after a period of ritual purification, treating the mountain's slopes as a threshold between ordinary daily life and something more sacred beyond it. Each step upward understood as a small act of devotion rather than simply physical exertion. Artists across many centuries have returned to this same mountain again and again as well, capturing its symmetrical form in countless paintings and prints. A single, steady, dependable silhouette recurring endlessly throughout the visual culture of an entire nation, admired as much for its calm, unchanging presence as for the quiet volcanic power patiently resting beneath its peaceful slopes across the wide stretch of Indonesia, where volcanoes rise in such abundance that daily life has, for many communities, always unfolded in close and careful relationship with them. Similar traditions of respect and offering have persisted across many centuries. Certain volcanic craters have long been regarded as sacred sites, believed to serve as a dwelling place for spirits or ancestors, and traditional ceremonies held with quiet regularity continue even now. Offerings of fruit or flowers or small woven goods carried carefully up steep volcanic slopes and released gently into the crater below. Gestures of gratitude and respect extended toward mountains, understood not as inert stone, but as living, attentive presences deserving of careful, ongoing relationship. In certain communities, harvest festivals are timed specifically to honor these mountains. Entire villages gathering to carry offerings upward together in a single, unhurried procession. A shared communal gesture, repeated faithfully across generations, regardless of how quiet or active the mountain happens to be in any particular year. In the high mountains of the Andes, where volcanic peaks rise among some of the tallest and coldest terrain found anywhere on Earth, indigenous traditions have long held certain mountains as powerful guardian spirits, protectors watching over the communities settled in their shadow. these mountain spirits were, and in many places still are honored through careful ceremony and offering, approached with the same kind of respect one might extend to a wise and powerful elder, rather than treated as simply another feature of the landscape. Herders and farmers alike have long looked to these mountains for guidance as well as protection, reading the presence or absence of snow upon their peaks as a quiet signal about the coming season's rains, treating the mountain not merely as a distant guardian, but as an active, ongoing participant in the practical rhythms of daily life. Even now, certain of these traditions continue quietly alongside modern life. An old and patient relationship carried forward across many generations without any need to fully set aside more contemporary ways of understanding the same mountains. It is worth pausing here for a moment to notice a pattern that seems to hold true across nearly every one of these old traditions, however distant from one another they may otherwise be. Volcanoes across nearly every culture that has ever lived near one have rarely been understood simply as dangerous obstacles to be avoided. Far more often, they have been understood as powerful living presences, deserving not fear alone, but genuine respect, approached the way one might approach any great and unpredictable force of nature, carefully, humbly, and with proper acknowledgement of one's own comparatively small place in the world. This makes a certain quiet sense when you consider how closely so many communities have lived alongside these mountains across so many generations, sometimes for periods of time so long that no single family history could ever fully recall a time before the mountain's presence was simply assumed. A volcano rarely announces itself only through occasional dramatic moments. Far more often, it simply exists nearby, day after day, season after season, its rich soil feeding crops, its warm springs offering comfort, its steady, looming presence becoming as familiar a part of daily life as any river or forest or coastline might be. It is little wonder that people who lived so closely and so continuously alongside these mountains came over many generations to feel that something more than simple stone must be present within them, something worth naming, worth honoring, worth including as a genuine member of the community, rather than simply an indifferent backdrop to it. There is a particular kind of quiet wisdom worth carrying forward from these old traditions. Even now that we understand so much more about magma chambers and tectonic plates than any of these earlier storytellers ever could, these old beliefs, whatever their differences, all seem to agree on one quiet point: that living alongside something as vast and as powerful as a volcano calls for a certain humility, a willingness to treat the mountain as something deserving genuine respect, rather than something to be casually dismissed or carelessly ignored, whether that respect takes the form of careful offerings left quietly at a crater's edge, or the careful scientific monitoring we will explore later in our own journey together. The underlying impulse remains remarkably similar across every single century separating one from the other. A quiet acknowledgement that something this old, this powerful, and this deeply patient deserves our full and careful attention. As you rest here tonight, perhaps you might imagine, gently and unhurried, all these old stories resting quietly alongside one another. Vulcan at his forge, Peel within her fiery home, a sacred snow-capped peak, rising toward a devoted sky, ancestral spirits watching patiently over familiar slopes, each one simply a different, equally sincere attempt to make sense of something vast and warm and alive, resting deep within the earth. You do not need to choose between them at all. You need only let them settle together quietly in your mind. Old stories from old people who, like you, simply wanted to understand and honor the great, warm mystery resting beneath their own feet, and who found, each in their own way, a story gentle enough to rest their own minds upon at the end of a long day. Let your own thoughts settle now the way old stories settle quietly into memory, layer upon gentle layer, each one adding its own small warmth to the whole, until everything rests calm and honored fully ready at last for sleep. A mountain we have learned across this long journey together rarely tells its story in a single chapter. It builds slowly, rests quietly, wakes occasionally, and changes shape again and again across a span of time far longer than any single human memory could ever hold whole. Tonight, let us follow one particular mountain across many such chapters, watching it rise, rest, wake, and rise again. Long before and long after the single famous morning we spent time with earlier in our own journey together, this mountain rests along the warm, sunlit southern coast of Italy, near the edge of a wide, sheltered bay, and it belongs, in shape, to the same family of steep, layered stratovolcanoes we explored together some time ago, built patiently across many thousands of years, from countless alternating layers of hardened lava and fallen ash, each eruption adding its own thin new layer to a structure already many centuries in the making. Its position here is no accident. Deep beneath this stretch of coastline, one portion of the Earth's crust is slowly sliding beneath another, feeding this same restless mountain the same steady supply of rising, gas-rich magma that builds so many of the world's great stratovolcanoes. Wherever plates meet and slide in that particular way, this same slow collision, quiet and patient, and largely unnoticed by anyone living far above it, has shaped this entire stretch of coastline across an immense span of geological time. This one particular mountain, simply the most visible, most storied expression of forces that have been quietly at work here for far longer than any settlement along this coast has ever existed, long before the famous morning that buried the two quiet towns we visited together earlier. This mountain had already lived through countless earlier chapters, entirely lost to any written memory at all. Ash layers preserved deep within the surrounding soil tell us, in their own quiet and patient language, of eruptions stretching back many thousands of years before any person nearby ever learned to write a single word down. Each layer a patient, silent record left quiet quietly behind long before there. Was anyone present to describe it in their own words? Patient study of these buried layers, comparing their thickness and composition, one against another, has allowed careful researchers to reconstruct something of this mountain's deep, unwritten past, revealing a long history of alternating rest and activity, stretching back far further than any single chapter most people associate with this particular peak, a history that continues to grow more detailed and more complete with each new careful excavation and each new patient season of study. The mountain's slopes in those distant early centuries would have looked rather different from the shape we recognize today. Its profile gradually reshaped again and again by successive eruptions, each one adding new material in one place, while occasionally removing older material in another. The mountain slowly redrawing its own outline, the way a river slowly redraws its own banks. Patient revision rather than any single final design. Entire earlier structures, larger or differently shaped than what stands today, appear to have risen and later collapsed or eroded away across these distant centuries. This single mountain, in truth, better understood as a whole quiet succession of related volcanic structures, layered one atop another, rather than as one single unchanging peak, standing patiently across the whole of time. In the long centuries before its most famous eruption, the mountain appears to have rested quietly for a stretch of time long enough that those living in its shadow had, by all appearances, largely forgotten its volcanic nature entirely. Its lower slopes, richly fertile from centuries of settled volcanic ash, had been given over gradually to vineyards and orchards and comfortable homes. The mountain itself, regarded by many in that particular quiet century as simply a pleasant green backdrop to daily coastal life, rather than a sleeping giant requiring any particular caution. Its steep upper slopes, covered in wild green growth, rather than the bare volcanic rock later generations would come to recognize so readily. This long, quiet rest, followed eventually by such a dramatic and sudden reawakening, offers a gentle reminder of something worth carrying with us throughout this entire journey. That a volcano's silence, however long it lasts, is never quite the same thing as its ending, following that famous eruption we explored earlier. The mountain did not simply return to permanent stillness across the many centuries since. It has continued its long, patient rhythm of rest and renewed activity, waking periodically to release fresh lava or ash before settling again into quiet for a stretch of years or decades, or occasionally far longer. Its behavior across this entire span, following the same uneven, unhurried conversation between rising pressure and available release that we explored when we first walked through the anatomy of an eruption. Some of these later awakenings passed with only modest, contained, gentle activity, small flows of lava creeping quietly down already familiar slopes, scarcely disrupting daily ordinary life in the surrounding towns, beyond a period of watchful, careful caution. Others proved more forceful, reshaping the mountain's summit once again, occasionally even altering its overall height and visible profile in ways plainly visible to anyone who had known the mountain well in earlier years. Tall, dark plumes of ash rising once more into the quiet sky above the same wide bay that had witnessed so many earlier quiet chapters of this same long, patient story. One particularly notable and significant reshaping occurred when a significant portion of the mountain's original summit, weakened perhaps by the very same forces that had built it, collapsed inward during a period of especially vigorous activity, leaving behind a wide, encircling ridge, the remnant of that older, larger structure, surrounding a smaller, newer cone that has continued growing quietly within it ever since. This kind of collapse tends to happen when a magma chamber empties itself with unusual speed during a particularly forceful eruption. The ground above suddenly finding itself without the support it had relied upon for so long, sinking gently inward the way a tent might sag once its central supporting pole has been removed, leaving behind a wide, bowl-shaped depression where a solid peak had stood only shortly before. This pattern, an older, larger volcanic structure, partially collapsing and giving rise to a smaller, more recent cone nestled within its remains, is not unique to this particular mountain, but it is especially visible here. The older ridge and the newer inner cone standing together as a kind of layered autobiography, each ring recording a distinct chapter in the mountain's long and uneven life. A visitor standing today upon that outer, older ridge can look directly across the wide depression toward the smaller, younger cone rising steadily within it, seeing in a single glance two entirely different chapters of the same mountain's long story, standing quietly side by side, one ancient and largely settled, the other considerably younger, and still, from time to time, quietly active across the many centuries following its most famous chapter. This mountain settled into a rhythm, neither entirely quiet nor entirely restless. Periods of noticeable activity separated by longer stretches of calm. The surrounding towns and cities gradually rebuilding, resettling, and expanding across the very same fertile slopes that had proven so difficult to resist despite their occasional volcanic temperament. Each generation living quietly in its shadow seems to have arrived in its own particular way at a similar quiet accommodation with the mountain nearby, benefiting gratefully from its rich soil and gentle climate, while accepting with varying degrees of concern the occasional reminder that the same ground offering such fertile abundance also carried, somewhere beneath it, the same patient warmth that had reshaped this landscape so dramatically once before. Paintings and writings from many different centuries capture this same mountain in countless different quiet moods, sometimes shown wreathed gently in a thin plume of quiet steam against a calm blue sky, sometimes depicted mid-eruption, glowing orange against a darkened evening, each image a small window into how one particular generation happened to encounter this same patient, restless neighbor in more recent generations. The mountain has rested in a stretch of relative quiet. Its most recent period of activity now resting several generations back in living memory, long enough that many who live nearby today have never personally witnessed it in any active state at all. This quiet, however long it continues, has not gone unwatched. The very same patient scientific attention we will explore more fully later in our journey, careful monitoring of small tremors, subtle ground movement, and shifting gas emissions continues quietly around this mountain even now, a modern echo of the ancient reverence and respectful attention so many cultures have shown toward volcanoes across every century we have explored together tonight. This modern watchfulness carries a particular weight here that it may not carry quite so heavily elsewhere. Since the mountain today rests beside one of the more densely settled coastlines found anywhere in this part of the world, countless homes and towns spread quietly across the very same fertile slopes that drew settlement so many centuries before it, where older generations relied on quiet observation, careful attention to smoke or tremor, or the subtle behavior of animals nearby. Today's careful watchers rely instead on sensitive instruments capable of detecting the smallest stirring deep within the mountain long before any change would ever be noticeable to an unaided eye or ear standing quietly upon its slopes. The underlying impulse, however, remains exactly the same as it has been for every single generation that came quietly before. A patient, ongoing attentiveness toward a neighbor whose long silences have never, in this mountain's entire recorded history, proven to be permanent, there is something worth sitting with. In this long, uneven biography, stretching across so many centuries, so much longer than the single famous chapter most people associate with this particular mountain's name, a volcano's life, we are reminded once again, is rarely defined by any single moment, however dramatic that moment might be. It is instead an ongoing, patient conversation between rest and activity, extending backward through countless quiet centuries before any written record began, and continuing forward just as patiently into a future no one alive today can fully predict. Each new chapter simply the latest entry in a story that began long before any of us arrived to witness even a small part of it. The famous morning we spent time with earlier in our journey together was, in truth, only one single page within a much longer, much older book. A page that happens to have been read and remembered more widely than most of the others, simply because of the particular careful way it was written and preserved. Perhaps there is something quietly reassuring in this longer view as you rest here tonight. A single dramatic chapter, however memorable, however widely remembered across so many centuries afterward, is never truly the whole story of anything, whether a mountain or a life. There were countless quiet centuries before that chapter, and there have been countless quiet centuries since. Ordinary rhythms of rest and renewal, continuing steadily onward, mostly unremarked, mostly unremembered by history, and yet no less real or no less patient for having drawn so little attention to themselves. Your own life, too, holds far more quiet chapters than dramatic ones, and it is often those quieter chapters, gathered patiently one after another across many ordinary years, that carry the greatest and steadiest share of the whole story in the end. Let your own evening settle now into that same long, patient rhythm, the quiet chapters mattering just as much as any louder one. Each ordinary night simply another gentle entry in the long, unhurried story of a life well lived, resting now, exactly as it should, in calm and settled stillness, ready for whatever quiet chapter tomorrow happens to bring. Sound, ordinarily, is a small and local thing. A voice reaches only a room. A bell reaches only a village. Even the loudest thunder, however startling nearby, fades to nothing within a relatively short distance, swallowed gently by the wide, absorbing quiet of open air surrounding it on every side. Tonight, we visit the one remarkable exception to this gentle rule. A sound so vast it did not simply fade as it traveled, but circled the entire curved surface of our planet again and again, before it finally, patiently, grew still. This sound came from a small island resting quietly within a narrow strait between two larger islands. In the warm waters of what is now Indonesia, a place we spent some time with earlier when we walked through the volcanic geography of the wider ring of fire. This particular island had, for a great many years, sat mostly unremarkable, a modest volcanic peak rising from the sea, known to those living nearby, but otherwise unremarked upon by the wider world. Its slopes covered in quiet green growth, its presence simply another familiar feature along a strait busy with fishing boats and trading vessels passing steadily to and fro. And then, across a period of tremendous and sustained activity, the mountain released so much pressure so suddenly that the resulting sound did something sound almost never does. It refused to fade. To understand why, we should return briefly to something we explored when we first walked together through the anatomy of an eruption. A sound wave at its very heart is simply a wave of pressure moving outward from its source, growing gradually weaker as it spreads across an ever-widening area. In much the same way gentle ripples on a pond grow gentler, and gentler the further they gently travel from the spot where a stone first broke the water's surface. Ordinarily, even a very loud volcanic eruption produces sound waves that follow this same familiar pattern, impressively loud near their original source, but fading steadily to nothing within a fairly modest, ordinary distance. What made this particular eruption so extraordinary was the sheer scale and suddenness of the pressure it released. A release so immense that it did not simply produce an unusually loud sound. It produced something closer to a true pressure wave in the atmosphere itself, a genuine disturbance in the air pressing outward in every direction with such tremendous initial force that ordinary distance alone was not enough to fully absorb it, where an ordinary loud sound might be thought of as a single strong ripple gradually smoothing itself out across a pond. This was closer to dropping an enormous stone into that same pond all at once. A disturbance so large that the water itself, for a time, seemed to forget how to simply settle back into stillness. This wave, rather than gently fading into silence, the way ordinary sound does, instead continued traveling outward across the entire surface of the globe, eventually circling the earth entirely, passing quietly over oceans and continents alike, detected clearly by sensitive barometric instruments in places so distant from the eruption itself that no person there could have possibly heard anything with their own ears, and yet the instruments, quietly and faithfully, recorded the pressure waves' passage all the same. These instruments, designed originally to track the ordinary rise and fall of atmospheric pressure that accompanies everyday weather, found themselves instead tracing a single, enormous, coherent pulse moving steadily across their recording paper, a shape unlike anything the careful observers watching over them had ever encountered before, arriving with a punctuality so precise that its passage could later be timed almost to the moment, confirming beyond any doubt that this single disturbance truly had traveled the entire distance around our world. This traveling wave of pressure did not pass by only once, having circled the entire globe from end to end. It continued onward, circling again a second time, and by some careful and patient accounts, continuing on for several additional passes still, growing gradually gentler with each full circuit. The way ripples on a pond grow gentler with each widening ring, until eventually, after many patient days and nights of quiet, repeated travel, the disturbance finally settled entirely. Its enormous initial energy at last fully and completely dispersed across the whole of the world's atmosphere, sound and pressure, in this remarkable case, traveled hand in hand, but were not quite the same thing. The audible portion, the sound a human ear could actually register as sound, carried an extraordinary distance in its own right, heard clearly across waters and islands, separated from the eruption by a distance so vast it is genuinely difficult to hold comfortably in the mind. A sound many people, at the time, mistook for distant cannon fire or thunder from some storm not otherwise account for. Reports gathered afterward from these distant listeners described a sound not unlike heavy artillery fire, distant and repeated, prompting some to check their own harbors for ships in distress, entirely unaware that the true source lay across an expanse of ocean too vast to easily imagine any single sound successfully crossing. Meanwhile, the lower, quieter pressure wave, entirely below the threshold of ordinary human hearing, continued its own separate journey around the globe, detectable only to careful instruments rather than to any listening ear. This distinction between what a person could hear and what an instrument could measure marks, in its own quiet way, a meaningful moment in how people came to understand the natural world, a recognition that some events are simply too vast to be fully grasped by human senses alone, requiring instead careful instruments capable of noticing what our own ears, however attentive, were never quite built to detect. There is something worth quietly sitting within this distinction. Quiet human hearing on one hand, patient scientific instrument on the other, each capturing a different portion of the very same enormous event. The sound that people actually heard, however far it carried, was still, in the end, a fundamentally human scale experience, something someone somewhere could describe afterward in their own words. A noise, a boom, a distant rumble mistaken for something else entirely. The pressure wave that the instruments recorded, meanwhile, belonged to an entirely different scale altogether, something too vast and too quiet for any single person to directly perceive. A disturbance in the very fabric of the atmosphere itself, circling a whole planet the way a ripple circles a still and patient pond. The eruption's effects did not end with sound and pressure alone. Enormous quantities of fine volcanic ash and tiny particles were thrown high into the upper atmosphere, rising far above the altitude where ordinary clouds or weather typically form. And once there, these fine particles began drifting slowly around the globe as well, carried gently along by high atmospheric winds, for a considerable stretch of time afterward. Sunsets in places entirely unconnected to the eruption itself took on an unusually vivid, deeply colored quality, brilliant reds and oranges, lingering in the sky well after ordinary sunset would typically have faded to darkness. The fine volcanic particles, high above, scattering the day's fading light in ways no one watching from below could easily explain, until word gradually spread of the distant eruption responsible for painting skies so far from its own quiet island. These extraordinary evening skies appeared across an enormous stretch of the globe, from bustling cities to quiet coastal towns, entire populations pausing at day's end to watch colors overhead, unlike anything within living memory. Some describing the sky as appearing almost to smolder gently at the horizon, long after the sun itself had properly set. In certain places, the unusual brightness was pronounced enough that alarmed observers reported what they believed to be distant fires burning somewhere just beyond the horizon, prompting fire brigades in more than one city to be called out entirely in error, searching for a blaze that existed nowhere, but in the sky's own strange and borrowed color. Artists and writers in many different countries, entirely unaware at first of any connection to a distant volcanic island, found themselves moved to capture these unusually vivid evening skies in paint and in words, unknowingly creating a quiet, scattered record of the very same distant event. Each cherished sunset, a small, gentle echo of a single mountain's tremendous release, carried across oceans, not as sound or pressure this time, but as light itself, subtly reshaped by fine dust, drifting patiently through the upper air. In the aftermath of this tremendous release, the island itself was profoundly reshaped. Much of its original structure collapsing inward in the same manner we explored when we spoke of calderas earlier in our journey, leaving behind, for a time, little more than a submerged remnant where a modest volcanic peak had once quietly stood. For many years afterward, that stretch of sea remained simply open water, marked on charts as the site of a mountain that no longer broke the surface. Its story seemingly concluded its fire. It seemed to many finally and permanently spent, and yet this was not, in the end, a permanent ending for this particular patch of restless sea floor. Some years later, quiet volcanic activity resumed in precisely the same location. Magma once again finding its way upward through the same weakened crust, gradually building a brand new island, rising slowly from beneath the waves, patiently reconstructing, layer by careful layer, a mountain in almost exactly the same place its predecessor had once stood. Sailors passing through the strait began noticing. First, only a slight discoloration in the water, then a small patch of steam rising from the surface, and eventually, unmistakably, a small dark cone breaking through the waves entirely, growing steadily taller with each passing season as fresh eruptions added their own new material to its slowly rising form. This newer island came to be known, quite fittingly, by a name meaning child of the mountain that came before it, a name chosen by those who recognized immediately that this was no separate, unrelated volcano, but a direct continuation, a fresh chapter written by the very same restless hand that had authored the tremendous release we spent this evening exploring. This newer island continues its own quiet, patient growth even today, still occasionally active, still slowly adding fresh material to its steadily rising cone, a direct and living continuation of the very same volcanic story that produced so many generations ago a sound loud enough to circle the entire earth. There is something quietly moving in this continuation, a reminder that even the most tremendous single release, a volcano, can produce rarely marks any true ending at all. Simply another chapter within the same long, patient story of rising heat and settling stone that we have followed together throughout this entire journey. Perhaps there is something worth carrying from all of this into your own rest tonight. Something about the way even the loudest, most overwhelming moments eventually soften, spread thin, fade into a wider and gentler quiet. That tremendous sound, once loud enough to circle an entire planet, grew softer with every widening circuit, until at last, after many patient days, even it settled fully into silence, leaving behind only the same steady, ordinary quiet that had rested over that same strait long before the mountain ever stirred at all. Whatever noise or worry your own day may have carried, it too can soften in exactly this same way, spreading gently outward, growing quieter with every passing moment, until it settles at last into the same wide and patient stillness that eventually welcomed even the loudest sound our restless earth has ever produced. Let your own thoughts settle now the way that vast and traveling sound settled, circuit by widening circuit, softer and softer, until nothing remains but calm, wide, welcoming quiet, ready to hold you gently until morning arrives. We spent a little time in an earlier chapter of this journey together with the way certain eruptions can paint distant sunsets in unusually vivid colors, fine ash and dust drifting high through the atmosphere and scattering the day's fading light in soft, borrowed hues. Tonight, we turn our attention to a quieter, slower cousin of that same phenomenon, one that unfolds not over a single evening, but across an entire season, sometimes even across several seasons in a row, gently lowering the temperature of the whole wide world for a time. Not every eruption is capable of this particular effect. It requires a very specific and somewhat delicate combination, an eruption forceful enough to hurl material not merely into the lower sky where ordinary weather lives, but higher still into the calm, steady layer of atmosphere resting above it, and a magma chemistry rich enough in a certain kind of gas to matter once it arrives there. When both of these conditions are met together, the result is something quite different from the more familiar picture of falling ash we explored when we visited two quiet towns earlier in our journey. It is instead an invisible veil, thin and widespread, capable of gently dimming the sun itself across an entire hemisphere, sometimes across the whole of the earth at once. The particular ingredient responsible for this effect is a gas containing sulfur released from magma in enormous quantities during especially forceful eruptions. Once this gas reaches that high, stable layer of atmosphere, it undergoes a slow chemical transformation, combining gradually with water vapor already present there to form countless tiny droplets, each one smaller than the finest mist, together forming a thin, pale haze spread quietly across a vast stretch of sky. This transformation does not happen all at once. The way the initial eruption itself unfolded in only a matter of hours or days. Instead, it continues gradually across many following weeks and months, the gas slowly converting itself into these tiny, suspended droplets a little at a time, the haze thickening steadily rather than appearing fully formed in any single dramatic moment, unlike ordinary ash, which is heavier and settles back down to earth within days or weeks. These tiny droplets are light enough and float high enough to remain suspended for a much longer stretch of time, drifting gradually around the entire globe on steady high-altitude winds, spreading themselves thin and even across latitudes far removed from the eruption that first created them, depending on where exactly the original eruption occurred on the globe. This drifting haze may spread primarily across one half of the globe, or, in the case of an eruption occurring closer to the planet's midline, may spread instead across both hemispheres nearly equally. The high winds at that particular latitude, carrying the fine droplets steadily in multiple directions at once, until the entire globe finds itself gently wrapped, however thinly, in the very same quiet veil. It is this high, thin, widespread haze that produces the cooling effect we are exploring tonight. Sunlight, on its way down toward the Earth's surface, passes directly through this newly formed veil, and a small but meaningful portion of that light is scattered back outward into space before it ever has the chance to warm the ground below. This is not unlike the gentle shade of fine, sheer curtain might cast across a sunlit room, not blocking the light entirely, but softening it, diffusing it, allowing noticeably less warmth to settle into the space beneath it. The droplets themselves are tiny enough that they do not darken the sky in any way. A person standing outdoors would necessarily notice at a passing glance the difference, registering not as visible shadow, but as a subtle, cumulative, gradual dimming, measurable through careful instruments long before it would ever be obvious to an unaided eye, simply looking upward on an ordinary afternoon. Multiply that same gentle softening across the entire surface of the planet, sustained not for a single afternoon, but for months, or even years at a stretch, and the cumulative effect becomes substantial enough to measurably lower average temperatures across huge and widely scattered portions of the globe all at once. It is worth appreciating just how small each individual droplet's own contribution truly is, and how patiently that smallness accumulates into something eventually significant. No single droplet blocks any meaningful amount of light entirely on its own accord. It is only the combined, patient presence of countless trillions of them, spread thin but continuous across the entire sky, sustained faithfully day after day for month after patient month, that gradually adds up to a genuine, measurable shift in how much warmth reaches the waiting ground below. This cooling rarely announces itself all at once, in any single dramatic moment. It arrives instead as a kind of quiet, gradual shift. Summers slightly cooler than expected, growing seasons slightly shortened, certain regions receiving noticeably less warmth than the same season had offered only a year or two before. Farmers in various parts of the world, entirely unaware of any distant eruption, might simply notice their crops taking longer than usual to ripen, or frosts arriving earlier in the year than anyone could readily remember. Small local disruptions that, taken individually, might seem like nothing more than an unlucky season. Yet, when examined together across a wide enough area, reveal the quiet fingerprint of the very same distant volcanic event. These local disruptions could take many different, ordinary seeming forms, depending on where in the world a particular community happened to live. In some regions, an unusually cool, damp summer might simply mean a smaller harvest than expected. Fields yielding somewhat less than their neighbors had come to rely upon in better years. In others, a season arriving unusually late or ending unusually early might shift the delicate timing that certain crops depend upon. A planting calendar carefully refined across many generations, suddenly finding itself slightly out of step with the actual rhythm of that particular year's weather. None of these individual experiences, taken alone, would necessarily point toward any volcano at all, resembling instead simply one difficult season among the many ordinary difficult seasons any farming community might expect to weather across a long enough stretch of years. Scientists studying this effect today have developed a number of patient, careful methods for tracing these cooling episodes long after they occurred. Methods entirely separate from written historical accounts, which do not always survive or clearly connect a poor growing season to its true distant cause. Deep within certain ice sheets, layer upon layer of snow, compacted slowly over many centuries, preserves a faint chemical record of these sulfur-rich eruptions, each notable volcanic event leaving behind its own small signature within the ice, a signature careful researchers can now read the way one might read the rings of an old and patient tree, each layer holding its own small chapter of the Earth's long climatic story. Extracting these long, narrow columns of ancient ice requires enormous patience and care. Researchers drilling steadily downward through countless accumulated seasons, each thin layer representing roughly a single year's worth of snowfall, compacted slowly into ice under the weight of everything that fell above it in the centuries since. Similarly, the growth rings preserved within very old trees sometimes reveal a season of unusually slow, thin growth, precisely lining up with a period of known volcanic cooling occurring elsewhere on the globe. The tree itself unknowingly keeping its own quiet record of a distant mountain's tremendous release. A tree, after all, tends to grow a little more generously in a warm, favorable season, and a little more sparingly in a cooler, quieter, more difficult one. Each year's individual growth rings slightly wider or slightly narrower, depending on the particular conditions that year happen to offer. By comparing these narrow rings across many different trees, sometimes across many different continents entirely, researchers can identify years when growth slowed simultaneously across an unusually wide stretch of the globe, a pattern far too widespread to be explained by any single local weather event, pointing instead toward the same quiet, far-reaching influence of a distant volcanic veil settling temporarily over the whole of the sky. There is something worth noticing in how differently this particular volcanic effect behaves compared to nearly everything else we have explored together in our journey, where a lava flow moves visibly and an ash column rises dramatically into plain view. This particular cooling effect moves quietly, invisibly, felt only gradually, over the passage of an entire season by people who may never once connect their disappointing harvest or their unusually chilly summer to any volcano at all, let alone one resting an ocean away, hidden behind a horizon they will never personally cross in their whole lives. It is a reminder that not every consequence of a great natural event announces itself with noise or spectacle. Some consequences arrive instead as a quiet, patient absence, a little less warmth than expected, spread thin and even across an entire hemisphere, felt by nearly everyone in some small way, and yet fully understood by almost no one at the time it was actually happening. It is worth noting, too, that this cooling effect, however significant it can become in any given year, always proves temporary in the end. The fine droplets suspended so high in the atmosphere do not remain there forever, however patiently they linger. Gradually, over the following months and years, they settle, disperse, and clear away entirely. The high atmospheric veil thinning steadily until sunlight once again reaches the surface with its full, unobstructed warmth restored. Temperatures that had dipped gently below their ordinary range slowly return in their own time to their familiar pattern. Growing seasons lengthen back to normal, and the quiet disruption, however widely felt while it lasted, eventually resolves itself entirely, the atmosphere clearing the way a held breath eventually, naturally, releases itself without any need for force. This slow return to warmth carries its own quiet lesson worth holding on to tonight. Even an effect capable of touching the entire globe at once, dimming sunlight itself across every continent simultaneously, still resolves in time, the world's climate finding its own patient way back to balance, without any need for intervention or repair. The same patient earth that occasionally cools itself this way is also the same patient earth that always, eventually, warms back to its familiar rhythm. The whole system settling itself gently back into place the way a disturbed pond eventually settles back into stillness, given nothing more than the simple gift of time. No special effort is required to hurry this return along, and no correction is needed from any outside hand whatsoever. The very same patience that produced the cooling in the first place is more than sufficient in the end to carry the whole system gently back toward its familiar warmth. Perhaps there is something quietly comforting in this as you rest here tonight. Even something as vast as a temporary chill spread across the entire globe eventually passes, resolving gently back into its familiar warmth without any need to force the process along. Whatever small disruptions your own day may have carried, whatever quiet chill may have settled briefly over your own mood or your own thoughts, it too can be trusted to soften and clear in its own good time. The way a high, thin veil eventually clears from even the widest and most distant sky, asking nothing more of you than the simple patience of waiting for it to pass. Let yourself settle now into that same patient trust, the quiet trust that warmth always finds its own way back, that quiet chills of any kind are always temporary, and that rest, like sunlight gently returning after a long, gentle season of dimness, will settle over you fully and completely, exactly when it is ready to arrive, no sooner and no later. Somewhere in the northwestern reaches of the United States, beneath a landscape so calm and so widely loved that millions of people walk across it every single year without a second thought, rests one of the largest and most patient volcanic systems found anywhere on the entire planet. Tonight, we visit this quiet, remarkable place, not to dwell on any distant possibility, but simply to understand, gently and without alarm, the patient architecture resting beneath its meadows and forests, and world-famous, ever-faithful springs we spent time earlier in our own journey together, with the patient hot spots that rise from deep within the mantle, remaining fixed steadily in place, while the great plates above them slowly drift onward, leaving behind long chains of volcanic mountains as they go. We explored one such hotspot beneath the islands of Hawaii, watching new volcanic peaks rise steadily from beneath the sea as the ocean floor drifted slowly overhead across countless patient centuries. Tonight's hotspot follows this very same gentle pattern faithfully. Only here, rather than resting quietly beneath an ocean, it rests instead beneath the wide, dry interior of an entire continent. This particular hotspot has been quietly active for a very long stretch of geological time, and the plate drifting slowly above it has, across all those many millions of years, left behind its own long trail, not of individual island peaks rising one after another from the sea, but of a series of enormous volcanic calderas, each one marking a place where the plate once rested directly above this same patient, rising heat. Tracing this trail across a map reveals a long, gently curving path stretching across a considerable portion of the surrounding landscape. Each older caldera along that path, now quiet and deeply weathered, its dramatic origins softened by many centuries of rain and wind, patient erosion. Until today's landscape, sitting directly above the hotspot marks, simply the newest, most recent stop along this same long, unhurried journey, this trail, wide and shallow, and stretching across a considerable expanse of open land, tells the same essential story we encountered when we followed the Hawaiian island chain, only written here across dry continental rock rather than across the floor of an ocean. Each older caldera along this path, though no longer volcanically active in any meaningful sense, still shapes the landscape resting above it even now. Its ancient volcanic rock, weathered into rolling hills and fertile river valleys, the deep fire that once built each one having long since given way to entirely ordinary, peaceful countryside. Someone walking across this older stretch of the trail today would notice nothing at all to suggest a volcanic origin. The landscape, having settled fully and completely into the same quiet, unremarkable calm that eventually comes to every volcanic landscape, given patience enough and time enough to arrive there. The word supervolcano, which so often accompanies any mention of this particular place, refers not to any special kind of danger, but simply to scale, to the sheer size of the volcanic system resting beneath the surface here, considerably larger than the more familiar stratovolcanoes and shield volcanoes we have spent so much time with throughout our journey together. Deep beneath the park's peaceful meadows rests an enormous chamber of partially molten rock, vast beyond ordinary comparison, patiently gathering heat in the very same manner we explored when we first walked through how magma forms, only here on a scale considerably grander than almost anywhere else on Earth. This chamber does not exist as a single open cavern of pure liquid rock, the way it is sometimes imagined. Instead, much like the partial melting we explored earlier in our journey, it is better understood as an enormous region of mostly solid rock, threaded throughout with pockets and channels of genuinely molten material, the overall system holding far more warmth and far more slow, patient potential than any single small chamber could. Yet still, at any given moment, composed mostly of solid stone, rather than any continuous body of open liquid fire. This distinction matters a great deal for understanding how such a system actually behaves. Since a chamber of this character tends to change slowly, gradually, over long stretches of time, rather than shifting suddenly from one state to another within any single human lifetime. It is this same vast chamber of gathered heat that quietly powers the landscape's most beloved and most visited features. The geysers and hot springs scattered generously across the park, drawing so many visitors each year to watch heated water rise faithfully into the sky, are not separate from the volcanic system resting below. They are, in fact, its gentlest and most visible expression. Small, safe, everyday reminders that considerable warmth continues to rise patiently from somewhere far beneath the surface, finding its way upward through countless narrow cracks and channels in the surrounding rock, rainwater and melted snow, seeping slowly downward through the porous ground, eventually meet rock warmed by the heat rising from below. And this warmed water, growing lighter as it heats, begins its own slow rise back toward the surface. Exactly the same buoyant principle we explored when we first followed magma on its own patient journey upward. In certain places, this warmed water simply pools gently at the surface, forming the wide, brilliantly colored hot springs so many visitors pause beside. Their vivid blues and oranges, owing not to the water itself, but to hardy, heat-loving microorganisms living contentedly within it, each color marking its own particular temperature and its own particular community of tiny, patient life. The coolest edges of these springs, temperate enough for a much wider variety of these small organisms to comfortably survive, often display the warmest, most vivid oranges and yellows, while the very hottest centers, where only the very most heat-tolerant among them can persist and thrive, frequently glow in the deepest, most brilliant and vivid blues imaginable, the entire spring becoming, in effect, a living thermometer, painted patiently across its own surface by countless quiet generations of the smallest possible residents in other places. The underground plumbing narrows just enough to create the conditions for something more dramatic still. Water heated well past its ordinary boiling point, held under pressure within these narrow underground channels, occasionally reaches a threshold where it flashes rapidly into steam, launching the water above it upward in a sudden, celebrated eruption of its own, considerably gentler in scale than the volcanic eruptions we have spent so much of our journey exploring, yet born from precisely the same underlying principle, pressure building patiently until it finally, briefly releases. This particular plumbing tends to be narrow and tightly constricted in just the right places, forcing water to gather and heat well past what it might otherwise ever reach in a more open, unrestricted channel. The narrow geometry itself acting almost like a natural, patient valve, holding pressure gently and steadily in check until it finally exceeds what the surrounding rock and water column can comfortably contain. The most famous of these geysers has become so reliable in its own gentle rhythm that entire crowds gather patiently to watch it, confident in a punctuality most geysers elsewhere in the world rarely manage to match. This particular reliability comes down largely to the unusually consistent shape and size of its underground plumbing, filling and heating at a steady, predictable pace that varies only slightly from one eruption to the next, allowing patient visitors, guided by careful predictions posted nearby, to gather in comfortable, relaxed anticipation rather than uncertain waiting, watching together as the very same patient cycle of gathering, heating, and gentle release plays out yet again, precisely as it has for as long as careful visitors have been keeping count. This entire gentle system, springs and geysers, and warmly steaming ground, offers something worth appreciating in its own right. A landscape where the deep volcanic architecture we have spent this whole journey exploring becomes something visitors can witness directly and safely, without any need to imagine or extrapolate from a distant memory of ash or lava. Here, the patient heat rising quietly from below simply announces itself gently, day after day, in colors and warmth and rhythm, rather than anything more forceful or sudden. A quiet, ongoing conversation between the deep earth and the open sky that anyone willing to walk a boardwalk can witness firsthand for themselves. It is natural, given the scale of the volcanic system resting beneath this particular landscape, to wonder about its future behavior. And it is worth addressing that wondering directly and calmly. This system is watched continuously and carefully by patient scientists using the same careful monitoring tools we will explore more fully later in our journey, tracking subtle shifts in the ground's height, tiny tremors far too small to be felt by anyone walking above them, and small changes in the temperature and composition of the many springs and geysers scattered across the park. This careful, ongoing attention has, across many years of patient observation, revealed a system that remains, for now, in the same quiet, stable rhythm it has held for a very long stretch of time. Its heat expressing itself gently through springs and steam, rather than through any indication of significant change on any timescale meaningful to a single human life. This same patient attention has also given researchers a remarkably detailed picture of how such systems tend to behave in the long stretches of time before any significant change would ever occur. Small, gradual shifts unfolding across many years or decades, offering ample warning long before anything resembling the dramatic reshaping we explored in earlier chapters of our journey together. A system this closely watched, in other words, is one whose slow rhythms are already deeply familiar to the careful researchers keeping faithful watch over it. Familiar enough that any genuine shift from that long-established rhythm would be noticed early, patiently, and calmly, long before it could ever become a matter for anything other than careful, ongoing scientific interest. There is something worth appreciating fearing. In the sheer scale of quiet patience, this entire system represents the calderas scattered along this hotspot's long trail took shape across enormous stretches of time. And whatever this particular landscape's own future may eventually hold, it too will unfold according to the same unhurried, patient rhythm that has governed every other volcano we have explored together throughout this entire journey. A rhythm measured comfortably in centuries and millennia, rather than in any single restless afternoon for now and for a very long stretch of time yet to come. This landscape offers itself simply as a place of quiet natural wonder. A wide, forested park where bison graze peacefully across open meadows, where rivers run clear and cold, and where here and there the deep, patient warmth of the earth rises gently to the surface in color and steam and faithful, rhythmic release. A landscape that manages remarkably to be both one of the largest volcanic systems on the entire planet and one of the most peaceful, most beloved places any visitor could ever hope to wander through. Perhaps there is something worth carrying from this into your own rest tonight. A reminder that even something vast and powerful can express itself gently, patiently, in small, faithful rhythms, rather than through any need for dramatic display or sudden urgency. The same deep warmth that could, in some distant and unhurried future, reshape an entire landscape spends its days, instead simply warming a spring, lifting a plume of gentle steam, keeping faithful time with a geyser that has never once, in living memory, failed to keep its patient appointment. Let your own evening settle now into that same quiet, faithful rhythm, warmth rising gently rather than forcefully, patient rather than urgent, trustworthy in its steady nightly return the way. A beloved geyser is trusted to rise again, right on time, exactly as it always has, night after patient night. If you could drain every ocean from the surface of the earth, even briefly, even just long enough to properly look, you would discover something most people never have any reason to consider: the volcanic activity We have spent so many nights exploring together the mountains and lava flows and patient rising heat represents only a small visible fraction of the volcanism actually occurring on our planet. Far more of it, by a considerable margin, happens quietly beneath the waves, hidden from ordinary view by miles of dark, cold, patient water. We have touched on pieces of this hidden world already. The long ridges where plates gently separate, the pillow-shaped lava that forms when molten rock meets the sudden chill of the sea. Tonight, let us sink more fully into that hidden world, following the volcanic activity of the ocean floor in its own right, rather than simply as a footnote to the stories we have already told, giving this quiet, hidden majority of our planet's volcanism the fuller attention it has earned. The vast majority of the Earth's volcanic eruptions, by most careful estimates, occur along the hidden mid-ocean ridges rather than on visible land at all. This makes a certain quiet sense once you recall the shape of these ridges, tracing an almost unbroken path across every major ocean basin, far longer in total distance than every land-based mountain range combined, winding beneath every major sea on the planet in one single, continuous, patient seam. Along this entire hidden length, magma rises continuously, gently, and almost constantly, new ocean floor being created in a slow, patient, ongoing process that receives none of the attention any land-based eruption would immediately attract, simply because so very few people are ever present to witness it directly. This constant, quiet activity along the mid-ocean ridges produces some of the most remarkable features found anywhere within the volcanic world. Features born from the meeting of two forces that might, at first glance, seem entirely opposed to one another. Tremendous subterranean heat and the crushing, cold pressure of the deep sea. In certain places along these ridges, seawater seeps down through cracks in the freshly formed ocean floor, drawn ever deeper by the same patient heat rising from below until it meets rock so hot that the water itself becomes superheated, its temperature climbing far beyond what water at the surface could ever tolerate without simply boiling away, held instead in liquid form by the immense pressure of the deep ocean pressing down upon it from every side. This superheated water, having traveled deep into the crust and gathered considerable heat and dissolved minerals along the way, eventually finds its way back upward, rising through narrow chimneys built from the very minerals it carries, venting back into the surrounding ocean in dramatic, billowing plumes, where this mineral-rich water meets the near-freezing water of the deep sea. The dissolved minerals it carries rapidly solidify, the sudden cooling causing them to precipitate out of the water almost instantly, building tall, dark chimneys around each vent that continue growing, layer by mineral layer, for as long as the vent remains active. Some of the most striking of these chimneys, thick with fine, dark mineral particles billowing continuously from their openings, have come to be known simply as black smokers, a name that captures quite plainly the dramatic plume of dark, mineral-laden water pouring steadily from their narrow mouths into the surrounding blackness. These chimneys can grow to considerable height across the years. They remain active, some collapsing under their own weight, only to begin building again from the same tireless vent. Others standing for long stretches as slow mineral towers, rising steadily from the ordinary seafloor around them. Not every hydrothermal vent announces itself with quite the same dramatic plume. In certain places, the water rising from below carries far less mineral content, or has cooled somewhat on its journey upward, venting instead as a clearer, gentler stream, sometimes called a white smoker for the pale, milky minerals it deposits rather than the dark, iron-rich particles of its more dramatic cousin. Elsewhere still, warmth simply seeps upward through the seafloor in a slow, diffuse manner, with no true chimney forming at all. The surrounding rock and sediment merely warmer to the touch than the ordinary seafloor around it, a gentler, quieter cousin to the same deep volcanic heat, offering just enough warmth in places to support smaller, more modest gatherings of the same specialized chemistry-loving life found in greater abundance near the more dramatic vents nearby. It would be reasonable to assume that such an extreme environment, crushing pressure, scalding water, and complete darkness, all combined together at once, would host no life at all. And yet these hidden vents support some of the most remarkable and unexpected ecosystems found anywhere on our entire planet. Entire communities of specialized creatures thriving in conditions that would be lethal to nearly any other living thing, gathered densely around each vent, the way a desert oasis draws every form of life for a great distance around it. What makes this life possible is a particular kind of chemistry entirely separate from the sunlight-based process that powers nearly every other ecosystem on the surface of the earth above. Here, in the permanent darkness of the deep ocean floor, certain specialized microorganisms have developed the remarkable ability to draw energy directly from the chemical compounds dissolved within the vent water itself. Using that chemical energy in place of sunlight to build the basic building blocks of life, these microorganisms form the true foundation of the entire vent ecosystem, gathered in dense, pale colonies directly upon the surrounding rock, providing nourishment, whether directly or indirectly, for every other creature drawn to these strange, hidden oases scattered across the ocean floor around this foundation. Gather a whole community of specialized creatures found almost nowhere else on Earth. Pale crabs picking their way carefully across mineral-crusted rock, translucent shrimp clustering in great numbers near the warmest currents a vent produces, and tall, tube-shaped worms, some taller than a person, entirely lacking mouths or digestive systems of their own, relying instead on colonies of these same chemical processing microorganisms living directly within their own bodies, an intimate partnership allowing worm and microorganism alike to thrive together in an environment that would otherwise offer neither one any means of survival at all. These worms grow with a speed remarkable for such a lightless, pressurized environment. Their bright red plumes, rich compounds their inner partners depend upon, retracting swiftly at the first sign of disturbance, the way a shy creature might withdraw at the approach of an unfamiliar shadow. These vent communities remain remarkably isolated from one another, scattered across the ocean floor, the way islands are scattered across the surface of the sea, each one separated from its neighbors by vast stretches of ordinary, food-poor seafloor, entirely unable to support this same dense, specialized life. And yet, somehow, these isolated communities manage to spread and persist across immense distances and immense stretches of time, their tiny larvae drifting patiently through the deep ocean currents, occasionally finding their way to some other distant, newly formed vent, and there, quietly, beginning the whole remarkable process anew. A single vent, too, does not last forever. Its underlying source of heat eventually shifting or fading. And when it does, the entire community gathered around it must eventually give way as well, leaving behind only the slowly cooling mineral chimneys as a quiet monument to a community that thrived there once, briefly, in the darkness. Beyond these dramatic vent communities, the ocean floor holds countless other volcanic features scattered widely across its surface. Seamounts rising from the deep floor, the way mountains rise from ordinary land. Some reaching heights considerable enough to rival the tallest peaks found anywhere above the waves, though almost entirely unknown to anyone beyond the small community of researchers who study them directly. Many of these underwater mountains formed from the very same hotspot activity we explored earlier in our journey. Patient plumes of rising heat building volcanic structures entirely upon the seafloor, some eventually rising high enough to break the surface as visible islands, many others remaining forever hidden beneath the waves, their peaks resting still a considerable distance below the surface, unseen by any but the most determined and well-equipped explorers. Some seamounts rise alone, isolated points of volcanic activity scattered across otherwise ordinary seafloor, while others cluster together in long chains, quiet echoes of the same patient hotspot trails we traced when we followed the islands of Hawaii across their own slow, unhurried journey. Many of these seamounts, despite never breaking the ocean's surface, still support their own remarkable communities of life. Their hard volcanic slopes offering rare, solid footing amid the soft, otherwise featureless sediment of the surrounding deep floor, stretching for miles in every direction, corals and sponges, some growing with a patience spanning many centuries, cling to these rocky slopes in great abundance, drawing in the small drifting nutrients carried past them by deep ocean currents. Their slow, steady growth marking the passage of time in much the same unhurried way tree rings mark the passing seasons on dry land far above. Each ring or layer a quiet record of one more patient year spent in the permanent, undisturbed dark. It is worth sitting for a moment with just how little of this hidden volcanic world we have actually managed to explore directly. Even now, far more of the deep ocean floor remains entirely unmapped in any real detail than has ever been carefully surveyed, meaning that countless undersea volcanoes, hydrothermal vents, and entire hidden ecosystems almost certainly remain completely unknown to us even today, quietly existing in the permanent darkness of the deep sea, entirely indifferent to whether any curious human eye will ever happen to find them. Each careful expedition that does manage to reach these hidden depths tends to return with some new, unexpected discovery, a vent no one had previously charted, a seamount rising taller than anyone had suspected, a small community of creatures entirely unknown to science before that particular quiet, patient journey downward. There is something worth carrying from this vast, hidden world into your own rest tonight. A reminder that warmth and life and quiet, patient activity can flourish even in the deepest darkness, in places entirely beyond ordinary sight, needing no audience and no recognition to continue their own steady, ancient rhythms. Whatever quiet processes are unfolding within you tonight as you rest, whatever small repairs and gentle restorations your own body performs, while your mind lets go of the day, these two continue faithfully in their own kind of darkness, unseen and unwitnessed, yet no less real or no less important for happening quietly, out of sight, exactly the way the deep ocean floor has kept its own patient, hidden fires burning for longer than anyone has ever been able to properly count, just as those hidden vents ask for no audience to keep faithfully warming the water and stone around them. Your own quiet rest tonight needs no witness either, unfolding fully and completely, simply because it is exactly what this moment and this body require. Let yourself sink now, the way warmth sinks gently downward into cold, deep water, settling comfortably into whatever quiet darkness rest requires, trusting that everything necessary continues to unfold exactly as it should, even in places and even in moments that no one else will ever directly see. There is a particular kind of birth that happens nowhere on land, a birth witnessed by almost no one, unfolding entirely beneath the surface of the sea until, quite suddenly, it is not hidden any longer. Tonight, let us follow this birth from its first quiet beginning to its final settled form, watching an island rise from nothing at all into solid ground, capable of holding forests and villages and centuries of ordinary human life. We have followed pieces of this story already. Hot spots building islands one after another as a plate drifts slowly overhead. A young volcano rising again from the very same strait where an older one once collapsed. Tonight, let us step back from any single example and simply follow the general shape every volcanic island shares, regardless of which particular volcanic process happened to build it. Every volcanic island begins its life entirely underwater, whether fed by a fixed hotspot or by the restless meeting of two tectonic plates along a subduction zone deep beneath the waves. Eruption after eruption slowly builds a mountain from the ordinary seafloor upward. Each flow of lava cooling instantly upon meeting the cold surrounding water, fracturing into the same pillow-shaped forms we explored earlier in our journey. Layer settling gently upon layer across a span of time long enough that no single eruption alone could ever hope to account for the whole. For a very long stretch of this early life, the growing volcano remains entirely invisible, its summit still resting some considerable distance below the surface, patiently climbing closer with every fresh eruption. Yet, utterly unknown to anyone above, its entire early existence unfolding in complete secrecy beneath countless fathoms of undisturbed, indifferent water, eventually, given enough patient repetition, the volcano's summit draws near enough to the surface that its eruptions begin to change character. Where deep water once smothered each eruption almost instantly, cooling it before it could ever behave as it might in open air. The shallower water near the surface allows something different to happen. Steam and gas, trapped within rising magma, can now expand and escape far more violently than they could at greater depth, producing sudden, explosive bursts of steam and ash that breach the surface of the sea in dramatic, billowing columns long before any solid land has actually formed. These early eruptions are a kind of announcement rather than any solid arrival. A mountain clearing its throat, so to speak, before it has anything solid to show for itself just yet. Brief dark columns rising and dispersing again into open ocean air, repeated again and again as the mountain below continues its slow, patient climb. This particular stage, neither fully hidden nor fully arrived, can persist for a considerable stretch of time. The same patch of ocean occasionally erupting in dramatic, temporary bursts, without ever quite managing to leave behind anything solid enough to survive the sea's constant, patient attention. Sailors passing through such waters might occasionally witness one of these brief, dramatic bursts. Plumes of steam and ash rising suddenly from otherwise open water, only to watch the disturbance settle again within hours. The ocean's surface closing back over smoothly, as though nothing at all had happened. The true drama continuing, invisible, in the patient mountain, still climbing steadily below, only with continued, patient activity does the volcano finally break the surface for good, fresh lava, and ash finally piling up faster than the restless sea can wash it away. The newest, thinnest edge of land at last standing above the waves rather than beneath them. This first appearance is rarely stable in any permanent sense. Young volcanic islands are often built from loose, poorly consolidated ash and fragmented rock, entirely vulnerable to the same restless waves that failed to prevent their birth, but continue patiently to wear away at their edges every single day thereafter. Many such young islands rise, briefly hold their place above the water, and then, within a matter of months or years, are worn back down beneath the surface once more. Their brief visit above the waves, ending almost as suddenly and quietly as it began, leaving behind only a shallow, submerged rise to mark where solid land had, however briefly, once stood. Only those volcanic islands fed by continued, sustained eruption manage to survive this vulnerable early stage, fresh material, arriving faster than the waves can remove it, gradually building a more solid, lasting foundation capable of resisting the sea's endless patient erosion year after year. Once an island survives long enough to establish this more durable foundation, an entirely new chapter of its story can begin. One having nothing at all to do with fire, and everything to do with life, finding its way to a place that, until quite recently, did not exist at all. A newly formed volcanic island begins as entirely barren ground. Nothing but cooling rock and ash, offering no soil, no shelter, and no nourishment to any living thing, and yet life, patient and persistent, rarely takes very long to begin its own quiet colonization of this fresh, empty land. The first arrivals tend to come by air or by sea. Spores and seeds carried on ocean currents or borne along by distant winds, occasionally arriving clinging to the feathers or feet of seabirds passing overhead in search of a place to rest. Lichens, needing almost nothing beyond bare rock and patience, are often among the very first living things to settle successfully upon this new ground, slowly beginning the long, patient work of breaking down solid stone into the first thin traces of actual soil. A process so gradual that a single generation of lichen might contribute only the faintest, barely measurable improvement before giving way to the next. Insects, too, often arrive remarkably early in an island's life. Some carried great distances on storm winds, entirely by accident. Others simply drifting on debris across open water until they happen, by pure chance, to wash ashore on this same isolated patch of new land. A surprising number of these earliest arrivals fail to survive their unlikely journey, or find themselves entirely alone upon arrival, without any companion of their own kind to continue their line. Yet across the sheer abundance of attempts made by wind and wave and wing over many centuries, enough manage to arrive successfully, and in sufficient number that a young island's population of plants and creatures gradually, patiently, begins to take shape over time, measured not in seasons, but in centuries. This thin, hard-won soil gradually deepens and enriches itself, supporting first modest grasses and low shrubs, then hardier trees capable of tolerating salt-laden coastal winds, and eventually, given enough patient time, entire forests capable of supporting birds, insects, and whatever other creatures happen to find their own way across the open water to this same isolated, hard-won home. Each new arrival, having crossed considerable open ocean to reach this place, often finds itself remarkably free from the predators and competitors that might otherwise have limited its numbers on a larger, more crowded landmass, allowing strange and wonderful variations to develop across many patient generations. Unique creatures and plants found nowhere else in the entire world, shaped entirely by the isolated, hard-won nature of the island that first gave them a foothold. Meanwhile, in the shallow, sunlit waters surrounding a young volcanic island, an entirely different kind of life often begins its own patient work as well. Corals given warm enough water and enough time, gradually establish themselves along the island's shallow, underwater slopes, building a fringing reef that hugs closely to the shore, growing slowly outward and upward as generation after generation of tiny coral animals build their own hard skeletons atop those that came before them. This fringing reef, in its earliest stage, sits directly against the island's own shore, offering little separation between land and living reef. The calm water between them, barely wide enough to call a lagoon at all, as the centuries continue to pass. The volcanic island itself often begins a slow, gradual process of its own quiet decline. The same patient forces of erosion and cooling that eventually settle every volcano we have explored throughout our journey together, gradually wearing the peak down, while the entire island, cooling and settling upon the ocean floor beneath it, subsides ever so slowly back toward the sea. The coral reef surrounding the island, however, given warm enough water and enough time, can often grow upward at very nearly the same patient pace the island itself sinks. The living reef effectively keeping pace with its slowly disappearing volcanic foundation. Each generation of coral building just enough new growth atop the last to remain within reach of the sunlight. Its own survival depends upon. As this process continues across many further centuries, the reef gradually separates from the shrinking island at its center, forming what is known as a barrier reef, a growing ring of coral standing somewhat apart from the shore, with a calm, sheltered lagoon opening up in the widening gap between reef and rapidly diminishing island. The lagoon itself deepening gradually as the island beneath it continues its own slow, patient retreat. Given enough additional time, the volcanic island at the center may eventually disappear entirely beneath the waves. Its long volcanic life finally fully concluded, leaving behind only the living coral ring that had grown so patiently around it. A perfect circle of reef enclosing a calm lagoon where a tall volcanic peak once stood. The very transformation we touched upon briefly when we first explored the aging hotspot chain of Hawaii. This final quiet form, an atoll, represents the last chapter in a volcanic island's long, patient life. The fire that first built it long since extinguished. Its very foundation vanished beneath the sea, and yet something of it remains quietly in the shape and structure of the living reef that continues faithfully to mark the place where it once rose so dramatically from nothing at all. The lagoon at an atoll's calm center, sheltered by the surrounding ring of reef from the ocean's larger, more restless waves, often becomes its own quiet sanctuary, home to gentler creatures that might struggle to survive in the more turbulent open water just beyond the reef's protective boundary. There is something worth carrying from this entire long, patient story into your own rest tonight. A reminder that even the newest, most barren beginning can, given enough patience, become something rich with life, and that even a long, eventful life, however dramatic its middle chapters, eventually settles into its own quiet, gentle ending, leaving behind not emptiness, but simply a different, equally worthy kind of quiet. Whatever feels new or unfamiliar in your own life tonight, whatever ground feels freshly formed and not yet fully settled, know that patience alone, given enough time, has a quiet way of bringing forth exactly what that ground is ready to hold. Life finding its way, slowly and surely, to even the barest and most unlikely beginnings. Let yourself settle now the way solid ground eventually settles beneath a newly forming forest, patient and unhurried, trusting that whatever quiet growth is meant to happen here will happen in its own good time, exactly as it always has for every island that has ever risen from the sea. Throughout this entire journey together, we have followed heat rising patiently from deep within the earth, shaping mountains, building islands, and occasionally announcing itself in dramatic bursts of fire and ash. Tonight, we turn to a quieter, gentler use of that same deep warmth. The many patient ways people have learned to borrow a small portion of the earth's own heat for their own ordinary, everyday purposes far removed from any mountain or eruption, yet drawing from precisely the same deep and patient source, all the same, long before anyone understood the deep architecture of magma chambers and rising heat that we have spent so many nights exploring. People living near naturally warm springs had already discovered a simple, practical truth that certain waters emerging from the ground arrived already warm, sometimes even hot, without any fire or effort required to make them so. Across many different cultures and many different centuries, these naturally warm springs became gathering places, valued for bathing, for washing, and simply for the quiet comfort of sitting in warm water on a cold day. A gift offered freely by the patient earth below, without any machinery required to draw it forth. Some of these springs became so cherished across so many generations that entire towns grew up gently around them, built specifically to welcome travelers drawn from considerable distances by the simple promise of warm, mineral-rich water rising reliably from the ground year after year, regardless of the season or weather above. In time, people began to wonder whether this same deep warmth might be put to more deliberate use, not simply enjoyed where it happened to surface on its own, but actively drawn upward and directed toward specific, practical purposes. This wondering eventually gave rise to what we now call geothermal energy, a broad term covering the many different ways people have learned to capture and use the Earth's own patient heat, ranging from simple, modest applications, warming a single home, to elaborate systems generating electricity for entire cities. The most straightforward of these applications relies on nothing more complicated than moving naturally warm water directly to wherever its warmth happens to be needed. In certain places, naturally hot water rising close enough to the surface can be piped directly beneath streets and sidewalks, gently warming pavement enough to melt snow and ice through the coldest months of the year, without any need for salt or shoveling or plows. Entire neighborhoods staying clear and walkable through winter storms that would otherwise bury them beneath a considerable, treacherous depth of ice. Elsewhere, this same warm water might be piped instead into greenhouses, allowing crops to grow through seasons and climates that would otherwise make such cultivation impossible. The deep earth's steady warmth, substituting for the sunlight and mild temperatures such plants would ordinarily require, rows of vegetables and flowers thrive comfortably under glass, even through the coldest, darkest months of a northern winter, warmed entirely from below by pipes carrying the same patient heat that elsewhere on the very same island occasionally bursts forth as a dramatic geyser or a slow, glowing lava flow in many homes and buildings situated near a reliable source of this natural warmth. The same simple principle heats interior spaces directly. Warm water or steam circulating quietly through pipes, the way ordinary heating systems circulate warmth generated by burning fuel. Except here the warmth arrives already prepared, requiring no combustion and no fuel at all. An entire town, in certain fortunate places, might find nearly every one of its buildings connected to the very same network of underground pipes, warmth flowing continuously and reliably from a shared, deep source, rather than each individual home needing to generate its own heat separately. An arrangement offering not only considerable savings, but also a quiet, communal reminder of the shared warmth, resting patiently beneath every single home in town where naturally hot water is not quite so conveniently close to the surface. People have learned to reach a little further to find it, drilling deep wells down toward hotter rock in places where the deep earth's warmth runs closer to the surface than it does across most of the rest of the world. Water pumped down through one such well, upon meeting sufficiently hot rock far below, returns to the surface considerably warmer than it began, sometimes hot enough to have converted partially or fully into steam along the way. This heated water or steam can then be put to work in much the same fashion as the naturally occurring hot springs we began with, directed toward heating, or in more ambitious systems, toward spinning turbines connected to generators, converting the simple, patient rising of heated steam into the same electrical power that lights homes and runs machinery, all without burning any fuel whatsoever to produce it. These larger installations, sometimes covering considerable stretches of land above a particularly promising patch of underground heat, often involve not just one well, but many, arranged carefully across the surface to draw evenly from the same deep, shared source, without any single well drawing so heavily that it exhausts the warmth nearby. Wells depend upon as well. Careful engineers monitor this balance closely, adjusting how much water is drawn from any given well, and in some systems, returning cooled water back down into the ground once its heat has been extracted, allowing the same deep rock to reheat that returning water gradually, preserving the source for continued use across many decades, rather than depleting it prematurely through overly hasty extraction. This particular use of geothermal heat, generating electricity through the force of naturally rising steam, works remarkably similarly in principle to the vast, dramatic eruption columns we explored earlier in our journey. Gas and steam expanding forcefully as pressure eases. Only here that same expanding force is captured deliberately and gently, guided through carefully engineered turbines, rather than released suddenly into open sky. It is, in its own quiet way, the very same principle behind an eruption, borrowed, tamed, and put patiently to work, rather than allowed to release itself all at once in open, uncontrolled fashion. Certain places on Earth find themselves especially well suited to this kind of energy production. Generally, those resting atop unusually active volcanic regions, where the deep Earth's heat runs particularly close to the surface. We spent time earlier in our journey with one such place, the fire and ice of a certain northern island, where geothermal energy today provides a considerable share of both electricity and direct heating for homes and buildings across the entire country. Warm water drawn from deep beneath volcanic ground, circulating quietly through countless miles of pipe, rather rather than escaping visibly through any single dramatic spring or geyser. In such places, the same deep volcanic heat that has, across so many centuries, occasionally produced dramatic eruptions, also quietly, patiently, keeps homes warm through the coldest months of a long northern winter. The same underlying source expressing itself in two entirely different registers, depending on how directly and how suddenly its pressure happens to release. Visitors to such places often remark on the strange, comforting familiarity of a heating system whose ultimate source lies not in some distant power plant, but directly beneath their own feet. The very same ground that shaped the surrounding landscape's dramatic volcanic history, also quietly warming the water running through their morning shower, even in places lacking any particularly dramatic volcanic activity nearby. A gentler version of this same borrowed warmth remains available to nearly anyone willing to dig, only a modest distance below the surface, just a short way down, far shallower than any true geothermal well. The ground maintains a remarkably steady temperature year-round, considerably warmer than the coldest winter air, and considerably cooler than the hottest summer air. This steady underground temperature, reflecting not any deep volcanic source, but simply the slow, patient thermal memory of the ordinary soil itself, unaffected by the days passing, whether far above it, systems designed to draw on this shallow, steady warmth, circulating fluid through pipes, buried only a modest distance underground, can help heat a home gently through winter and cool it gently through summer, borrowing not from any volcano at all, but simply from the quiet, patient consistency of ordinary ground resting, undisturbed beneath our daily lives, unlike the deep wells and dramatic steam plants found only in especially volcanic regions. This gentler approach requires no particular geological good fortune at all, available in principle to nearly any home built upon nearly any patch of ordinary ground. A small, quiet echo of the same deep, patient warmth available in far more dramatic form, only a short distance further down than most such systems ever bother to reach. There is something worth appreciating in how many different scales this same underlying idea manages to serve. From a single quiet pipe warming one modest home to an entire national grid powered by deep volcanic steam, each one drawing in its own proportionate way from the same patient warmth that has been rising steadily from within the earth since long before any person existed to make any use of it at all. This warmth asks for nothing in return for its use, offering itself freely and continuously, day after day, regardless of whether anyone above happens to be drawing upon it in any given moment, patient in a way that few other sources of energy manage to match, requiring no burning, no depletion, no permanent taking away of anything the earth cannot easily replace. Perhaps there is something worth carrying from this into your own rest tonight. A reminder that warmth borrowed gently, without force or excess, tends to serve its purpose quietly and reliably, asking little in return beyond simple, patient acknowledgement of where it truly comes from. Your own body, too, carries its own quiet warmth this evening, generated gently, needing nothing more from you than rest in which to circulate comfortably, warming you through the night the same unhurried way the deep earth has warmed homes and greenhouses and quiet bathing springs for as long as anyone has thought to notice and make careful, patient use of it. There is a kind of trust worth noticing in this entire arrangement, a trust that asks nothing extraordinary of either party. The earth offers its warmth without condition, and those who borrow it need only build the simple, patient channels, a pipe, a well, a shallow buried loop, through which that warmth can travel to wherever it happens to be needed. No part of this arrangement requires force or hurry. It simply requires the patience to dig, to pipe, to wait, and to trust that the same warmth rising steadily today will continue rising steadily tomorrow, exactly as it always has. Let yourself settle now into that same borrowed warmth, gentle and steady, and entirely sufficient for tonight's quiet purpose, trusting that rest, like the deep earth's own patient heat, asks only that you allow it to circulate freely through you, undisturbed until morning. There is a quiet paradox worth sitting with tonight, one we have touched upon briefly in earlier chapters of our journey, but have not yet examined fully in its own right. Of all the places on earth people might choose to plant their crops and raise their families, some of the most fertile, most sought-after farmland anywhere in the world rests directly upon the slopes of volcanoes, the very same mountains capable, however rarely, of the dramatic transformations we have spent so many nights exploring together. This paradox has quietly shaped human settlement patterns across nearly every volcanic region on Earth. The same generous ground drawing farmers back again and again, generation after generation, even in places where an older, more dramatic chapter of that same mountain's history remains well within local memory. Tonight, let us understand why, gently and without alarm, examining the quiet chemistry that makes volcanic ground so remarkably generous to whatever seed happens to be planted within it. The story begins with the ash and fine volcanic material we followed earlier in our journey, rising from an eruption's tall, dark column and drifting slowly back down to settle across the surrounding land. This material, freshly fallen, is not yet soil in any meaningful sense, closer in character to fine, mineral-rich dust or gravel than to the dark, crumbling earth a farmer might recognize as ready for planting, but given time, patience, and the ordinary weathering that comes from rain and wind, and the slow passage of many seasons, this raw volcanic material begins a gradual transformation, breaking down bit by bit into something considerably richer than the material it began as. This weathering unfolds through the same patient, unhurried processes that shape ordinary rock everywhere, only considerably faster in volcanic material than in most other kinds of stone. The particular minerals common in freshly erupted ash tend to be less stable, chemically speaking, than the older, harder minerals found in ordinary bedrock. Having formed quickly under the sudden cooling of an eruption, rather than through the slow, careful crystallization we explored earlier when we spoke of how magma cools into different kinds of stone. This relative instability, rather than being any disadvantage, becomes instead the very quality that allows volcanic ash to break down into usable soil so much more readily than harder, more stable rock ever could, softening and dissolving gradually under nothing more than ordinary rain and time, releasing its contents steadily rather than holding them locked away for centuries longer. The way more resistant stone typically would. This transformation matters so much precisely because of what volcanic ash actually contains. Rock rising from deep within the earth carries within it a wide and generous variety of minerals, drawn from far below the surface, holding elements plants depend upon for healthy, vigorous growth in a form ordinary surface soil often lacks, or has long since depleted through repeated use. As rain falls upon fresh volcanic ash, season after season, it slowly dissolves and releases these minerals, delivering them gradually into the developing soil in a form roots can actually absorb. A slow, patient release, quite unlike the sudden depletion that can leave ordinary farmland increasingly tired and less productive after many years of continuous use, where an ordinary field might need deliberate replenishment, fertilizers, and careful crop rotation added by the hand of whoever tends it. Volcanic soil often continues offering fresh nutrients on its own. The deep mineral reserve within it, releasing gradually across many decades rather than being exhausted within only a handful of growing seasons. Volcanic soil, once it has had sufficient time to develop fully, tends to hold water remarkably well too. Its particular structure, often fine and porous, allowing it to retain moisture during dry spells while still draining adequately enough to avoid drowning the roots planted within it. This particular structure comes from the same fine, glassy fragments and porous, air-filled textures we explored earlier when we spoke of pumice and other volcanic stone, that same trapped air and delicate structure translating, once weathered into soil, into countless tiny spaces capable of holding water close to plant roots without ever allowing it to become stagnant or waterlogged. This particular combination, rich in minerals and generous with water, gives volcanic soil a reputation among farmers that has persisted across many different cultures and many different centuries, each independently discovering the same quiet truth, that ground shaped by fire tends to reward whatever is patiently planted within it far more generously than ordinary soil typically manages. It is this same rich soil that has, throughout history, drawn certain crops to volcanic slopes with remarkable consistency, regardless of which particular volcano or which particular corner of the world happens to be involved. Coffee grown on volcanic mountainsides is often prized for a particular depth and complexity of flavor that growers and connoisseurs alike attribute directly to the mineral richness of the soil feeding each plant's roots. The same patient chemistry that shapes a mountain stone somehow finding its way indirectly and gently into the cup a person might hold in their own hands many months later. Vineyards, too, have long favored volcanic slopes. The particular minerals present in such soil said to lend the grapes grown there a distinctive character, carried faithfully all the way through to the finished wine. Vintners across many different countries, independently arriving at the same fondness for these particular slopes, despite having no direct connection to one another beyond the shared volcanic character of the ground. They had each, separately, come to trust rice in certain mountainous regions is grown in elaborate terraces carved directly into volcanic hillsides, each terrace holding its own small, carefully managed pool of water and nutrient-rich soil, an entire agricultural tradition built quite deliberately around the particular generosity of this particular kind of ground. Generations of careful engineering shaping hillsides into a stepped, cascading landscape that has itself become, over centuries, as much a part of the region's identity as the volcano rising quietly above it. Given all of this, it becomes rather easier to understand why communities have, across so many centuries and in so many different parts of the world, chosen again and again to settle and farm upon the slopes of mountains, capable of occasional dramatic activity, a pattern we touched upon when we first explored ancient beliefs about volcanoes, and again when we followed the long, patient centuries surrounding one particularly famous mountain in southern Italy. The soil's generosity offered reliably across countless ordinary growing seasons weighs heavily against the comparatively rare possibility of dramatic disruption. A calculation each generation of farmers has made anew, usually without any explicit accounting at all, simply following the same quiet, practical wisdom passed down from the generation before them, that fertile ground is fertile ground, regardless of what rests patiently beneath it. This calculation, worth naming plainly rather than leaving unspoken, weighs a great many quiet, ordinary benefits, reliable harvests, richer flavor, healthier crops requiring less additional effort against a comparatively rare and usually distant possibility, one that most families living on any given volcanic slope will never personally witness across an entire lifetime, let alone across many lifetimes in a row. Framed this way, the choice to farm such ground looks considerably less like carelessness and considerably more like the same ordinary weighing of steady benefit against occasional risk that shapes nearly every choice about where and how to build a life, whether that life unfolds near a volcano, a river prone to occasional flooding, or a coastline exposed to occasional storms. This is not, it is worth saying gently, any kind of carelessness or forgetting. Communities living on volcanic slopes have, across many generations, developed their own patient understanding of the particular mountain nearby, learning its typical rhythms, respecting its occasional need for caution, and passing down generation after generation whatever practical wisdom helps a community live safely and productively alongside a neighbor capable of both remarkable generosity and, on rare occasion, remarkable disruption. Local knowledge of this kind, gathered patiently across many generations of careful observation, often proves remarkably sophisticated in its own right. A community's collective memory, serving much the same purpose as the careful scientific instruments we explored earlier in our journey. Both simply different methods of paying the same close, respectful attention to a powerful and patient neighbor, the same careful, ongoing attention we explored when we visited the monitoring of active volcanoes, serves this same quiet purpose today, allowing modern farming communities to benefit fully from volcanic soil's considerable gifts, while remaining thoughtfully prepared for whatever rare disruption might eventually follow. There is a particular kind of patience worth admiring in this entire arrangement. Farmers tending crops today that draw nourishment from ash that fell, in some cases, many centuries before any living memory could account for it. Minerals released slowly across generations, finally reaching a root system planted by someone who never knew and never needed to know the exact source of the ground's particular generosity. The mountain gives, quietly and continuously, long after any memory of its more dramatic moments has faded into simple local history, offering its long, slow gift to whoever happens to be tending the soil in any given season, asking nothing in return beyond the ordinary. Patient work any farmer would offer any soil at all. In this sense, every harvest drawn from volcanic ground carries within it a quiet collaboration spanning centuries, the mountain's ancient contribution and the farmer's present labor meeting patiently in a single humble crop neither one could have produced entirely alone. Perhaps there is something worth carrying from this into your own rest tonight. A reminder that even ground shaped by dramatic, sometimes difficult beginnings can become, given enough time and enough patience, something remarkably generous and nourishing. Whatever difficult or unsettled moments may have shaped your own path to this particular evening, know that difficult beginnings do not necessarily determine what eventually grows from them. That patience and time have their own quiet way of transforming even the roughest beginnings into something capable of sustaining and nourishing whatever comes to rest upon it, the same slow weathering that turns raw volcanic ash into rich, generous soil asks nothing more than ordinary time, rain falling gently and repeatedly, season after unremarkable season, until what was once harsh and unformed becomes, quietly and without any fanfare, exactly what was needed all along. Let yourself settle now into that same patient trust, the trust that whatever has weathered and settled within you across time has, in its own quiet way, become fertile ground for rest, rich enough and settled enough to hold you gently until morning, exactly the way patient volcanic soil holds and nourishes whatever has been entrusted to it, season after unhurried season. Throughout this entire journey, we have followed heat and stone and pressure, the patient inner workings of mountains, capable of both remarkable generosity and remarkable transformation. Tonight, let us turn our attention instead to the people who have devoted their own quiet lives to understanding these mountains directly, walking their slopes, sampling their gases, and listening patiently for whatever a particular volcano happens to be telling them on any given day. A devotion built not on any single dramatic discovery, but on countless quiet, ordinary hours spent in careful, attentive company with something far larger and older than themselves, a volcanologist at the simplest level is someone who has chosen to spend their working life in close, careful relationship with volcanoes, studying not from a comfortable distance, but often standing directly upon the same slopes we have spent so many nights exploring together, close enough to feel the warmth rising from a vent, close enough to hear the particular hiss and rumble a mountain makes when it is quietly going about its own patient business. This is not, by most accounts, a career chosen for comfort or convenience. It tends instead to be chosen by people who have found themselves genuinely fascinated by the deep, slow architecture of the earth toward mountains the way. Some people are drawn toward the sea or toward the night sky simply because something about their scale and their mystery speaks to a particular kind of curious, patient mind, a mind content to spend an entire career slowly answering questions that may never be fully, finally settled. The daily work of a volcanologist looks considerably less dramatic than popular imagination sometimes suggests. Long stretches of time are spent not amid dramatic eruption, but in careful, patient observation, walking a volcano's slopes on foot, gathering small samples of rock or ash or gas, noting subtle changes in a spring's temperature or a fumarole's particular smell, recording measurements that, on their own, might seem entirely unremarkable, yet gathered patiently over months and years, begin to reveal the deeper, slower rhythms of a mountain's ordinary life. A single day's field work might involve nothing more dramatic than hiking several hours across uneven volcanic terrain simply to reach one particular spring, taking careful measurements there and hiking the same distance back again. The entire day's effort reducible, in the end, to a small handful of numbers recorded carefully in a well-worn field notebook. Much of this work happens not on the volcano itself, but afterward, in a quiet laboratory, examining collected samples under careful analysis, comparing today's readings against the careful records kept by researchers who walked these same slopes years, sometimes decades before. This comparison across time forms much of the actual scientific value of the work. A single measurement meaning relatively little on its own, but gaining considerable meaning once placed carefully alongside every measurement that came before it. The true picture of a volcano's behavior emerging only gradually from the patient accumulation of thousands of individually modest observations, rather than from any single dramatic reading. This patient, unglamorous rhythm forms the true backbone of the field, far more than any single dramatic moment ever could. A volcanologist's understanding of any particular mountain deepens not through a single visit, but through years of returning to the same slopes, the same vents, the same quiet springs, building up, season after season, an intimate familiarity with a mountain's particular temperament. The same way a longtime friend comes to recognize another person's smallest, quietest moods long before any obvious change in behavior ever becomes visible to a stranger. Fieldwork itself requires its own particular blend of careful preparation and quiet courage. Sampling gas directly from an active vent means approaching heat and fumes that demand real caution and real respect. Protective equipment carefully checked beforehand. Escape routes considered in advance. Weather and wind direction weighed thoughtfully before any sample is ever collected. Collecting a fresh sample of lava when conditions allow it safely involves working quickly and carefully near material hot enough to reshape the very ground it touches. Every motion practiced and deliberate rather than rushed or careless. A long-handled tool often used to gather even a small sample from a safe, respectful distance, rather than approaching any closer than genuinely necessary. This is work that rewards patience and punishes haste. A discipline that experienced researchers pass down carefully to those newer to the field. Each generation of volcanologists inheriting not only scientific knowledge, but also the accumulated, hard-won wisdom of how to move safely and thoughtfully around a mountain that deserves nothing less than careful, ongoing respect. This inherited wisdom often passes down through the simplest, most practical of lessons, which direction the wind tends to blow at a particular hour, which paths remain stable underfoot, and which have grown treacherous since the last visit. How to read the particular quality of light through drifting steam that might signal a subtle shift worth noting carefully. None of these lessons could easily be written down in any textbook, passed instead directly from one careful researcher to another, quietly, in the field itself, the same way any skilled trade passes its most valuable knowledge from experienced hands to newer ones. There is a particular kind of listening this work requires, one worth appreciating in its own right. A volcano rarely announces its intentions clearly or all at once. Instead, it offers countless small, quiet signals. A slight shift in the color of escaping steam. A subtle change in the smell of sulfur carried on the wind. The faintest tremor felt underfoot that might mean nothing at all, or might mean the beginning of something worth watching closely. Learning to notice these small signals and to understand what they might mean when considered together rather than individually takes years of patient, attentive practice. The same kind of quiet expertise a skilled physician develops in noticing subtle signs of a patient's condition, or a careful gardener develops in reading the small, early signs of a plant's particular needs. This work also asks something less easily measured than any scientific skill. A particular kind of temperament suited to genuine uncertainty. Volcanoes, for all the careful science we have explored throughout our journey together, remain only partially predictable. Their deep, complex systems resistant to any perfectly confident forecast. Volcanologists learn across their careers to hold this uncertainty honestly, offering their best careful judgment while remaining humble about the limits of what any single measurement or observation can truly promise. A discipline requiring both genuine expertise and genuine humility held together simultaneously in the very same quiet, careful mind. This particular balance, confidence enough to offer a meaningful judgment, humility enough to acknowledge what remains unknown, tends to develop only gradually across many years of practice. Newer researchers often needing to learn, sometimes through their own early missteps, just how much confidence a given observation genuinely deserves, despite the very real demands and occasional real danger this work can involve. Those who choose it often describe a particular kind of quiet wonder that keeps drawing them back, season after season, to the same patient slopes. There is something genuinely moving, many say, in standing close enough to feel a mountain's own warmth rising directly from the earth, in watching fresh lava harden into new stone before your own eyes, in coming to know, slowly and intimately, a landscape shaped by forces old enough and vast enough to make an entire human lifetime feel briefly, wonderfully small. Many researchers describe an almost personal relationship developing over years with the particular mountain they study most closely, speaking of it with the same familiar fondness one might use for an old, complicated friend, someone whose moods are well understood, whose occasional difficult periods are met with patience rather than surprise, and whose quiet, ordinary days are appreciated every bit as much as any dramatic one. This work, quiet and patient as it so often is, ultimately serves a purpose reaching considerably beyond scientific curiosity alone. The careful observations volcanologists gather, season after patient season, feed directly into the monitoring systems that help keep entire communities safe, translating years of quiet, attentive field work into the kind of practical, protective knowledge that allows people to live confidently and productively alongside even the most powerful of neighbors. In this sense, every quiet hour spent sampling gas or recording a spring's temperature becomes, eventually, part of something considerably larger than any single researcher's own individual curiosity. A patient, ongoing act of care extended toward every community living within a volcano's reach. There is a particular satisfaction many researchers describe in knowing that even the quietest, most uneventful day of field work contributes meaningfully to this larger protective purpose, that a single careful measurement taken on an entirely ordinary afternoon with nothing remarkable happening at all might one day form a small but essential piece of the picture that helps a community make an important, timely decision. This knowledge tends to sustain researchers through the many long, quiet stretches that make up the great majority of the work. Each unremarkable reading understood not as filler between more exciting moments, but as the very substance of the work itself, patient and valuable in its own right, regardless of whether any dramatic moment ever follows it at all. There is something worth dedicated work into your own rest tonight. A reminder that patient, careful attention, offered consistently and without any need for immediate, dramatic reward, has its own quiet, considerable value, just as a volcanologist's understanding deepens slowly, visit after patient visit, rather than through any single dramatic revelation. Your own rest tonight need not arrive all at once either, but can simply unfold gradually, one small, patient breath following another, each one adding quietly to whatever calm accumulates across the whole of this night. No single breath needing to accomplish everything alone. Let yourself settle now into that same patient attentiveness, listening gently to your own small, quiet signals, the way a careful researcher listens to a mountain's, trusting that whatever rest is beginning to gather within you deserves the same unhurried, careful attention, and will, in its own good time, arrive fully and completely, exactly as every patient, well-tended understanding eventually does. We spent time in an earlier chapter of this journey with the patient people who study volcanoes directly, walking their slopes and sampling their gases with their own hands. Tonight, let us turn to the quiet instruments that extend those same careful eyes and ears far beyond what any single person could ever manage alone. Tools capable of listening to a mountain continuously, day and night, long after any human observer has returned home to rest. The most fundamental of these instruments listens for a mountain's tremors, small shivers and shudders passing through the rock as magma shifts and cracks its way toward the surface. A seismograph, at its simplest, is built to sense the smallest movements of the ground itself, registering vibrations far too subtle for any person standing nearby to ever feel directly, translating that faint trembling into a steady, continuous record. Researchers can study carefully afterward networks of these instruments placed at careful intervals across a volcano's slopes. Allow researchers to do more than simply notice that tremors are occurring by comparing the exact moment a particular vibration reaches each separate instrument. Careful calculation can reveal not only that something is moving underground, but roughly where beneath the surface that movement is actually happening, tracing the slow, hidden journey of rising magma, the way a careful listener might trace approaching footsteps by comparing which ear detects each footfall first. Not every tremor a seismograph detects carries the same meaning, and learning to distinguish between them forms much of the patient skill involved in this work. Some tremors arrive sharp and sudden, the same familiar signature of rock fracturing under strain that ordinary earthquakes produce everywhere on Earth, volcanic or otherwise. Others arrive instead as a longer, steadier hum, a signal more closely associated with fluid, whether magma or gas or water, actively moving through narrow underground channels. A distinctly different signature that experienced researchers learn to recognize the way. A musician learns to distinguish one instrument's particular voice from another within a larger, layered piece of music. Alongside this careful listening for tremors, researchers also watch closely for a mountain's own subtle changes in shape as magma gathers and rises within a volcano. The ground above it often swells, ever so slightly, the entire mountain stretching gently to accommodate the material rising beneath it. A change usually far too small and far too gradual to notice with the unaided eye, yet perfectly measurable by careful, patient instruments designed specifically to detect it. Precise measurements of a mountain's exact height and position, taken repeatedly across weeks and months, can reveal even the smallest sustained swelling. A mountain quietly growing by a distance no visitor could ever perceive directly, yet significant enough when tracked carefully over time to suggest that magma is indeed gathering somewhere beneath the patient, apparently unchanged surface. Some of these instruments rest permanently in place, fixed points recording their own precise position continuously across months and years, while others are carried out periodically by researchers themselves. Careful measurements taken and compared against those recorded on a previous visit. The two methods together, offering both a continuous, ongoing record and periodic, especially precise confirmation. Gas plays its own important role in this careful, ongoing observation as well. We explored earlier in our journey how gas dissolved within rising magma drives so much of an eruption's eventual behavior. This same gas often finds its way to the surface well before any magma itself arrives, escaping quietly through vents and fumaroles in advance of whatever activity might eventually follow. Careful researchers monitor not just how much gas a volcano releases, but the particular mixture of different gases present within it. Since certain proportions tend to shift in recognizable, informative ways as fresh magma rises closer to the surface, offering an early chemical whisper of change well before any tremor or swelling might make the same story more directly apparent. Some monitoring stations sample this gas directly and continuously, drawing a small, steady stream of air through sensitive instruments positioned permanently near an active vent, while other measurements are gathered periodically by researchers carrying portable equipment directly to a site. Each approach offering its own particular balance of continuous coverage and especially careful, detailed analysis. In more recent generations, satellites orbiting far above the Earth have joined this same patient watch, offering a perspective no ground-based instrument could ever achieve on its own. Certain satellites carry instruments capable of detecting subtle changes in a volcano's surface temperature from a considerable distance, noticing warmth rising from a slope long before any visible change would be apparent to someone standing directly upon it. Others use a technique capable of measuring extremely small changes in the ground's exact height across an entire volcanic region at once, comparing images taken from orbit at different points in time to reveal patterns of swelling or subsidence spread across an area far too vast for any single ground-based instrument to monitor alone. This view from above complements the patient, close-up work happening directly on a volcano's slopes, offering a wider more complete picture that neither perspective could achieve entirely by itself. The broad, sweeping view from orbit and the intimate, detailed view from the ground working together the way. A wide photograph and a close, careful sketch might together tell a fuller story than either image alone. This satellite perspective proves especially valuable for the many volcanoes scattered across remote or difficult terrain. Mountains rising in places too isolated, too dangerous, or simply too vast to maintain a dense network of ground-based instruments across every single slope where ground instruments cannot easily reach. A passing satellite can still quietly record its own useful measurements, offering at least a partial picture of a mountain's behavior, even in places where no researcher has ever had the opportunity to walk directly upon its surface. All of these separate threads of information, tremors, swelling, shifting gas, subtle changes in surface temperature, are gathered together and considered carefully as a whole, rather than relied upon individually. A single tremor on its own might mean very little. A slight swelling, considered alone, might simply reflect ordinary seasonal changes in groundwater rather than any volcanic activity at all. It is only when several of these separate signals begin shifting together in patterns recognizable from a mountain's own past behavior that researchers grow genuinely confident that something meaningful may be unfolding beneath the surface. This careful weighing of multiple independent signals against one another forms the true heart of modern volcanic monitoring. A patient, ongoing effort to listen as broadly and as carefully as possible, rather than placing excessive trust in any single measurement alone. It is worth returning gently to something we touched upon when we spent time with the researchers themselves, that even the most careful, comprehensive monitoring cannot offer perfect certainty about what any particular volcano will do, or precisely when these instruments extend human perception considerably, allowing researchers to notice changes far earlier and far more precisely than would otherwise be possible. But they do not remove the genuine complexity and genuine uncertainty inherent in predicting the behavior of a system as vast and as intricate as a volcano's deep, hidden plumbing. What careful monitoring offers instead is meaningful, well-informed probability, a considerably clearer picture of how likely certain kinds of activity may be within a given stretch of time, allowing communities and researchers alike to prepare thoughtfully rather than promising any perfect, guaranteed forecast. No honest science could ever truly deliver this honest acknowledgement of uncertainty, rather than undermining the value of careful monitoring, is precisely what makes it trustworthy in the first place. A system that claimed perfect, guaranteed prediction would deserve genuine suspicion, given how much remains genuinely unknown about the deep, hidden workings of any volcano's interior. Instead, careful researchers offer their most honest, well-supported assessment, openly acknowledging its limits, a kind of scientific honesty that ultimately serves communities considerably better than false, overconfident certainty ever could. This entire patient system of listening, tremors and swelling and shifting gas and satellite imagery, all considered carefully together, represents a remarkable extension of the same old, respectful attention people have paid to volcanoes since long before any of these instruments existed at all. The careful reverence of ancient traditions we explored earlier in our journey, now joined by careful measurement, both expressions in their own particular way of the same underlying impulse that something this powerful and this patient deserves our fullest, most careful attention. There is something worth carrying from this careful, layered attentiveness into your own rest tonight. A reminder that understanding rarely comes from any single signal alone, but from patiently gathering many small, quiet observations and considering them thoughtfully together. Whatever small signals your own body and mind are offering you this evening, a particular tiredness in your shoulders, a settling weight behind your eyes, a slow softening in your own thoughts. None of these signals need to be understood perfectly or all at once. Simply notice them gently, gathered together rather than examined individually, and trust that their combined, patient message is exactly what it has always been. That rest is welcome now and ready to arrive, needing nothing more from you than your own quiet willingness to let it. Let yourself settle now into that same patient, layered stillness, tremor and swelling, and quiet signal, all gathered gently together into one single, unmistakable message that everything necessary has already been noticed, and that nothing more remains to be done tonight except to rest. Everything we have explored together so far has unfolded here, on this one particular planet, within the familiar rhythms of its oceans and continents and drifting plates. Tonight, let us drift further still, past the edge of our own atmosphere entirely, to discover that this quiet, patient rising of heat from within a rocky world is not something unique to Earth at all, but a pattern repeated in its own particular way across many other worlds scattered throughout our solar system. Consider first the dry, rust-colored world nearest to us in this wider search, where a single volcano rises so vast in scale that it dwarfs anything found upon our own planet's surface. A mountain built the same slow, patient way as the shield volcanoes we explored earlier in our journey. Thin, fluid lava spreading gently outward across an enormous span of time, layer upon layer, without ever needing to compete against the same restless drifting plates that limit how large any single volcano can grow here on Earth, because that distant world's crust remains fixed in place, never drifting slowly overhead the way our own plates drift above their patient hotspots. A single volcanic source can continue feeding the very same mountain for an almost unimaginable stretch of time, building upward and outward without ever needing to abandon one peak and begin building a new one elsewhere. The result is a mountain whose gentle, sweeping slopes would take a traveler many patient days simply to cross on foot, rising to a height that dwarfs anything found on our own more restless, more frequently interrupted planet. Its gradual slopes, so gentle in places that a traveler standing partway up might struggle to tell, without careful instruments, that they were climbing a volcano at all, rather than simply walking across an unusually wide, unusually elevated plain. This same distant world's volcanoes appear, by all careful evidence gathered so far, to have fallen largely silent in more recent geological time, their fires resting now in the same kind of long, patient quiet we explored when we spoke of dormant volcanoes here on Earth, though considerably longer in duration and considerably more uncertain in its eventual ending. Whether that world's deep fires might ever stir again remains an open, patient question. One careful researchers continue to study with the same quiet attentiveness they bring to any volcano, however distant or however long dormant it happens to be, examining faint, weathered features across its ancient slopes for any small clue that might suggest whether its long silence represents a true, final ending, or simply another, especially patient pause between more distant chapters. Travel further still, past the warm inner reaches of our solar system, toward one of the giant, gas-wrapped worlds orbiting much further from the sun, and you will find perhaps the single, most volcanically active body known anywhere among all these many worlds. A small, rocky moon locked in a tight, demanding orbital dance with its much larger neighbor. This little moon's volcanic energy comes from nowhere, resembling the patient radioactive warmth or ancient primordial heat that powers volcanoes here on Earth. Instead, it comes from an entirely different source. The constant, rhythmic squeezing and flexing this small moon experiences as it is pulled first one way and then another by the combined gravity of its enormous neighboring planet and several other moons sharing its orbital neighborhood. This ceaseless flexing generates tremendous internal friction, warming the moon's interior continuously from within. The same way repeatedly bending a piece of metal back and forth generates a surprising amount of heat, only here sustained endlessly. Orbit after orbit. For as long as this particular gravitational dance continues, a warming that never has the chance to fade the way an ordinary planet's ancient heat gradually does, since the very same flexing that first created it continues faithfully with every single orbit. The result is a moon whose surface never rests, constantly repaved by fresh volcanic material, erupting from countless active vents scattered across nearly its entire surface. Plumes of material, sometimes rising to considerable heights above the thin, patient landscape below, before drifting gently back down to settle across ground already reshaped many times before, where our own planet's volcanoes rest, for the most part in long stretches of quiet between occasional activity. This small moon knows almost no quiet at all. Its restless, continuous eruptions, the direct and inescapable consequence of a gravitational embrace it can never fully escape. Its surface, as a result, appears remarkably young everywhere researchers have examined it closely, almost entirely free of the old, weathered craters that mark so many other worlds, simply because fresh material erupts and resettles across its ground far too quickly and far too frequently for any such ancient scarring to ever accumulate and persist. Not every volcanic world relies on rock and fire in quite the same way we have explored throughout our own journey. On certain especially cold, distant moons, far from the sun's gentle warmth, a different kind of volcanism unfolds entirely, one built not from molten stone, but from something considerably colder beneath thick, frozen crusts of ice. Some of these distant moons appear to hold vast, hidden oceans of liquid water, kept unfrozen not by any nearby sun, but by the same kind of gentle, gravitational flexing we just explored, warming their interiors just enough to keep water liquid far below their icy surface. On certain of these moons, this hidden water occasionally finds its own way upward, erupting not as glowing lava, but as towering plumes of water vapor and ice crystals rising high above the moon's frozen surface before settling gently back down phenomenon researchers have come to call cryovolcanism, ice playing the same role liquid rock plays in the volcanoes we have followed throughout our own warmer, rockier world. These icy eruptions, cold as their origin may be, follow remarkably familiar patterns once you consider them closely. Pressure building slowly within a confined space until it finally, briefly, releases through whatever narrow crack or vent happens to offer the easiest path upward. Precisely the same underlying rhythm we followed when we first walked through the anatomy of an ordinary volcanic eruption here at home, only here enacted in ice and water rather than in stone and fire. Some researchers studying these hidden oceans wonder quietly and carefully whether such warm, sheltered water, kept liquid for so long beneath such thick protective ice, might offer precisely the kind of patient, stable environment where simple forms of life could conceivably take hold, a possibility that remains, for now, an open and genuinely fascinating question rather than any settled conclusion. There is something worth appreciating in how faithfully this same underlying pattern repeats itself. However different the particular materials or particular triggers happen to be from world to world, wherever internal heat, however it happens to be generated, meets a solid outer shell with some pathway toward the surface. That heat tends to find its way upward eventually, erupting as rock on some worlds, as ice and water on others, each world simply offering its own particular version of the same patient, underlying story. We have spent this entire journey exploring here at home. The particular ingredients differ considerably from world to world. Molten stone here, flexing ice there. Yet the underlying architecture, a hidden reservoir, a rising pathway, a patient release, remains recognizably the same wherever it appears. A single elegant pattern the universe seems remarkably fond of repeating. Even Venus, our own closest planetary neighbor in size and character, appears covered almost entirely in volcanic rock. An entire world seemingly reshaped at some point in its history by volcanic activity on a scale difficult to fully picture. Its thick, hostile atmosphere and blistering surface offering their own quiet reminder that the patient rising of heat from within a rocky world is very nearly universal wherever suitable conditions allow, requiring no ocean, no life, and no particular resemblance to our own gentler world at all, whether that distant volcanic world remains active even now, or whether its own fires have simply settled into the same long, patient quiet we explored on our own dry, rust-colored neighbor. Remains another gentle, open question researchers continue to study with the same careful, unhurried patience we have followed throughout this entire journey. Perhaps there is something quietly comforting in learning that this pattern we have followed so closely across our own single planet echoes in its own varied way across so many other worlds entirely. The patient rising of heat from within, the slow building of mountains layer upon layer, the eventual quiet settling into dormancy. None of it belongs only to our own small, familiar corner of the universe. It is simply what rocky and icy worlds do, given enough internal warmth and enough patient time. A quiet, universal rhythm playing out on world after world, whether anyone happens to be watching or not, whether any traveler will ever cross those distant slopes or not. The rhythm itself entirely indifferent to whether it is ever witnessed at all. Let yourself settle now into that same wide, quiet rhythm, the same patient pulse that warms distant moons and builds mountains on worlds no traveler has ever walked, trusting that whatever gentle warmth still rests within you tonight is simply doing what warmth has always done everywhere, finding its own quiet way toward rest. We have walked a long way together tonight, and across many nights before this one, following heat from its deepest, most hidden origins all the way to the surface, and from the surface back down again and again, through mountain after mountain, world after world, we have sat with quiet chambers deep underground, walked the trembling edge of eruptions, held cooling stone in our hands, and drifted briefly the way out to distant, icy moons before returning home again to this same familiar earth tonight, in this final chapter before we close our journey entirely. Let us simply sit for a while with everything this long, patient story has quietly taught us about time and about the particular, gentle way destruction and renewal have always traveled together, hand in hand. Wherever a volcano happens to rise, nothing we have explored together moves quickly. Not truly. Even the most sudden, most dramatic eruption we visited was itself the release of pressure that had gathered slowly, patiently, across months or years or centuries beforehand. A single brief moment resting atop a foundation of vastly longer stillness, and every one of these dramatic moments, however forceful, however transformative, was followed always by an even longer stretch of quiet rebuilding. Ash settling into soil, lava cooling into new stone, life finding its way back, gradually and persistently, to ground that had only recently seemed entirely and permanently changed. This rhythm, gathering and release, disruption and renewal, appeared again and again throughout everything we explored. We watched an island collapse into the sea, and in time watched a new island quietly rise again in almost the very same place. We watched two ancient towns disappear beneath a gentle fall of ash, and discovered so many centuries later that this same burial had preserved their ordinary daily life in extraordinary, tender detail. We watched barren volcanic rock, offering nothing at first but hard, cooling stone, slowly transform, given patience and rain, and passing centuries into some of the most fertile ground found anywhere on earth. We watched a mountain's own long silence follow its most famous, most dramatic chapter, only to discover that even that silence eventually gave way, again and again, across many further centuries, to renewed activity, renewed rebuilding, renewed quiet. We even followed this same pattern far beyond our own planet entirely, watching distant moons flex and warm and erupt in their own patient rhythm. Ice and rock alike to the very same underlying pulse of gathering and release each time. What looked at first like an ending revealed itself, given enough time, to be something closer to a beginning, wearing an unfamiliar shape. There is a particular kind of patience embedded in every single story we have followed. A patience considerably longer than any human life, longer even than many human civilizations, and yet within that vast, unhurried patience, something remarkably tender and remarkably alive continues, unfailingly, to take root. Lichens settling onto bare volcanic stone, coral quietly building itself around a sinking island's shore. A single distinctive flavor developing in coffee grown on a mountain's fertile slope, carrying forward in some small, quiet way the memory of an eruption that occurred long before any of the people tending those plants today were ever born. A community of pale, patient creatures gathering faithfully around a hidden vent on the deep ocean floor, needing no sunlight at all to build their own small, thriving world. Time on this scale does not erase what came before. It simply transforms it patiently into something new, carrying forward pieces of the old within whatever shape the new eventually takes. Perhaps this is the quietest, most patient lesson volcanoes have to offer. One we have circled gently again and again throughout this entire journey, without ever quite naming it directly. Until now, nothing that happens, however overwhelming it might feel in its own immediate moment, is ever truly the final word. A mountain collapses, and a new one begins rising in its place. A town disappears beneath ash, and centuries later becomes a window into a life once lived. Barren stone becomes rich soil. A sound loud enough to circle an entire planet eventually, patiently, fades into silence. A chilled, dimmed sky eventually clears back into ordinary warmth. Every ending we followed throughout this journey turned out, upon closer and more patient examination, to also be a quiet beginning, waiting simply for enough time to reveal its true shape. This does not mean that difficulty or disruption should be dismissed or explained away. nothing in our journey together has asked you to pretend that transformation is always painless or immediate. Ash falling over a sleeping town was, without question, a genuine ending for those caught within it. What we have observed, gently and honestly, is simply that endings and beginnings tend to travel together far more closely than they first appear to. That the same event capable of ending one particular chapter is very often, given sufficient time, also capable of beginning another, richer one, even if that richer beginning takes many more years or many more centuries to fully reveal itself. This honesty matters. A comfort that pretends difficulty never truly happened is no comfort at all, only a quieter kind of dismissal. The comfort worth carrying instead is simply this: that difficulty and renewal are not opposites competing against one another, but companions traveling the same long road together, one very often making room eventually for the other to arrive. You have carried within you across this entire journey your own particular collection of endings and beginnings, difficult chapters and quiet renewals, moments that felt at the time entirely final, and moments of unexpected, patient growth that followed them eventually in their own good time. Whatever has recently ended in your own life, whatever ground feels freshly disturbed or freshly uncertain tonight, might, given the same patient time a volcano itself requires, become something you could not yet imagine from where you currently stand. Exactly the way barren volcanic stone could never have imagined in its own first cooling moments the rich forest or fertile field it would eventually become. You need not know tonight exactly what shape that eventual renewal will take. Only that renewal, given time, has never yet failed to arrive somewhere along this entire journey we have followed together. There is no need to rush toward whatever renewal is waiting quietly ahead of you. The mountain never rushes. The island never rushes. The soil never rushes. Each of them simply continues, patiently, faithfully, doing the next small thing that patient transformation requires, trusting the passage of time to carry the rest. And in doing so, each of them arrives, eventually, exactly where it needed to be. There is a kind of quiet faith embedded in this patience, not a faith that everything will be comfortable or painless along the way, but a faith that the same slow, patient forces capable of building an entire mountain, an entire island, an entire fertile field from nothing more than fire and time, are more than capable of carrying you, too, gently forward through whatever waiting still remains ahead of you tonight. As you rest now, at the close of this long, patient journey we have shared together, let yourself hold gently everything we have walked through: fire and stone, ash and soil, sound and silence, ending and beginning, each one folded quietly into the other, the way every volcano we visited folded its own destruction into its own eventual renewal. You do not need to resolve anything tonight. You do not need to finish becoming whatever you are gradually, patiently becoming. You need only rest, the way cooling stone rests, the way settling ash rests, trusting entirely that whatever quiet transformation is unfolding within you will continue faithfully, exactly as it should, for exactly as long as it needs to, long after your own eyes have closed and your own thoughts have finally, gently let go. Rest now. Everything that needed to happen tonight already has. Everything still to come will arrive exactly when it is ready, the same patient way it always has. For every mountain, every island, every quiet, settling grain of ash that has ever eventually found its way home. Sleep now, unhurried and complete, trusting the same patient rhythm that has carried every ending gently into its own quiet beginning. For as long as this earth has known how to breathe, we began this journey deep beneath your feet, in a warmth older than any mountain, any ocean, any living thing. We ended here, in the same quiet place, having wandered together through fire and stone, through islands rising and towns settling gently into ash, through sound that circled an entire planet, and cold that dimmed an entire sky, through moons far beyond our own that flex and glow with a warmth not so very different from the warmth that built every mountain we have walked together tonight. We have met gods imagined in ancient fire and scientists who spend their quiet lives listening for a mountain's smallest tremor. Farmers tending soil older than memory, and small pale creatures thriving in darkness no sunlight has ever reached. If you are still awake to hear these final words, know that it does not matter. Nothing about this ending requires your attention. You have already been carried far enough through the deep, slow patience of magma, finding its way toward the surface, through the quiet architecture of chambers and conduits, through lava cooling into obsidian and pumice and basalt, through hot spots holding their steady flame, while whole continents drifted slowly above them. Whatever you remember of it, and whatever you do not, has already done its quiet work. There is nothing left to learn tonight, and nothing left to hold on to. The mountains we visited will still be there tomorrow, patient as ever, keeping their same slow, unhurried time. Whether or not you carry a single fact forward into morning, the soil will still be rich and generous. The islands will still be rising and settling. The deep hidden vents will still be tending their strange, lightless gardens on the dark ocean floor. None of it needs you to remember any of it in order to continue. So let yourself release whatever you were holding on to. The way a mountain releases pressure it has gathered slowly across centuries, not violently, not all at once, but gently, in a long, slow exhale that asks nothing more of you than to let it happen. Let your shoulders soften into whatever is holding you right now. Let your breathing slow to match the patient rhythm of something that has never once been in a hurry. Let your thoughts, if they are still moving at all, simply drift the way ash drifts, settling softly, layer by layer, until everything is quiet and still and safely covered over, the way an entire buried town once settled quietly beneath a blanket it never asked for and found so many centuries later a strange and gentle kind of peace within it. You do not need to solve anything tonight. You do not need to finish anything tonight. Whatever is unresolved in your life can rest exactly where it is until morning. The same way magma rests in its chamber for centuries before it ever needs to rise. same way an island can wait patiently beneath the waves for as long as it takes before breaking the surface. There is no clock keeping quiet time on your rest. There is only the same slow, generous patience we have followed all evening, offered now to you freely, the way the earth offers its warmth to anyone willing to receive it. If your mind wanders back over anything we shared tonight, a sound that traveled around the world, a garden growing quietly in the shape of a place that fell asleep beneath ash, a small green island rising again where an older one once stood, a mountain in another sky flexing gently and glowing far above any human eye. Let it wander gently, without any need to hold on tightly or make sense of it. These are simply quiet images now, soft and formless, free to drift apart and dissolve the way clouds dissolve into open sky. There is no test waiting for you in the morning. There is only rest, offered exactly as generously as this planet has always offered its own deep warmth to anyone patient enough to receive it. Feel, if you can, the same quiet weight that rests over every sleeping volcano, that same reassuring, ordinary stillness that covers even the most restless mountain far more often than it covers anything dramatic at all. This is the true, ordinary state of things. Quiet, patient, unremarkable, and entirely enough. Whatever fire lives within you, whatever warmth or worry or wonder, can rest now the same way. It is not gone. It is only resting, the way every mountain we visited tonight eventually rests, gathering itself quietly for whatever comes next, asking nothing of you but time and the simple, ordinary permission to be still. Sleep now. There is nowhere else you need to be, and nothing else you need to do. Let the whole earth hold you the way it has held every quiet, sleeping thing across every one of its long, unhurried centuries. Patient, warm, and entirely unbothered by the passing of a single ordinary night. There is no mountain anywhere that has ever regretted resting. There is no ash that has ever regretted settling. There is no island that has ever regretted the long, quiet wait beneath the waves before finally breaking into open air. rest well. We will meet again on another night, beneath another quiet mountain. Whenever you are ready to wander gently back,